2 days, I'll be done with or I was planning, it was the plan, and I'll be on to the ECMA 262 to go through the standard and have my JavaScript engine that's faster than all current JavaScript implementations, updated to the 800-page standard. That'll take 2 months. 2 days left. Yeah, so I'm gonna couple minor setbacks and stuff, like real-time programming. Nothing goes as planned, so I'm gonna have to gut the program I have, and I'm gonna have to rewrite stuff, and I have another program. I don't know. It is what it is. I'm gonna turn on the other computer and get going. 2 days. If it'll turn on, it's got the world's worst, slowest hard drive in it. I didn't know the hard drive was that bad. I should have got a Samsung. I didn't get a Samsung because Samsung failed on me, so I was like, I'll try something different. This was the worst hard drive ever. So I'm gonna turn this thing on. It's probably why it doesn't boot, because the hard drive sucks. I get it now. So I'm gonna try to turn it on. Get going. Oh, it's working. That's great. Siri. I'm gonna have Siri read this golden standard for, I don't know, whatever. Yeah.
It is a syntax error if initializer is present and contains supercall is true.
I think it's reading.
Private identifier. It is a syntax. Identifier is constructed.
I wouldn't be surprised if it's not.
It is a syntax.
Because that's how modern technology and stuff seems to work.
It is a syntax error if any.
As in it doesn't work. That's what I mean by how it seems to work, because it doesn't seem to work. No matter how modern it is, it doesn't seem very modern.
It is a syntax error if contained.
Not at all. Nope.
List with argument is.
I mean, it's 2025, the year, and we still program in text editors.
S, capital E.
What the fuck?
E, F, I.
We have high level programming, and we program in text editors with text characters and stuff.
Capital T.
And we have folders with files. Nodes aren't nodes, and magical references supposed to be a thing, but we still have text files with, I guess we have emojis.
Wait is true. Fine.
Instead of adding something useful like text with links to other text files, they added to the character set emojis to express picture icons and stuff. They could have added to the character encoding, like a way to like colorize text or like mark text or like categorize text, but instead expression and like happy faces is what they went with, and little pictures and stuff. I don't know. Seems kind of stupid.
Method. The syntax.
Well, I guess it's modern, you know. Very modern.
The class element pars no door.
I like look up when the text editor came out.
Class element list. Class element. Kind of class element is construct.
Like I'll compare it to the modern text editor. Then I'm gonna try to get to work.
Head is not empty. Return head. 44. ECMA International 2024. 3. If class element.
Maybe a chatbot will know.
Return class element. Return empty. 5. 7. For static semantics. Is static. The syntax directed operation is static, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Class element. Method definition. Return false. Class element. Static method definition. Return true. Class element. Field definition. Return false. Class element.
So it looks like the text editor, or one of them, came out in 1971. The text editor came out in 1971, okay, for editing text.
Non-constructor elements takes no arguments and returns a list of class element pars nodes. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is.
I'll just ask a chatbot what's changed about text editors since 1971.
Class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then append class element to the end of list. 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property.
It says text editors have evolved enormously, right, since 1971.
Prototype property name list.
Text editors have changed across several dimensions, apparently, even though they just edit text still. I mean, CAD and design, you go from 2D paper to 3D on the computer. Text editors, you go from text editing in 2D with characters to text editing in 2D with characters. I don't know.
Type property name list of class element.
Oh, no, I take that back. We have live preview and we have a blinking cursor. So, you know what? I guess that text editors have advanced since 1971. I'll have a Siri read it. You know what? This is actually, I don't know what I'm complaining about. There's actually a lot that's going on for text editing and programming.
Text editor release date. JS Fiddle. Code Playground. To NENS JS Fun.
I don't understand why Siri reads like, okay, I don't know.
1. Interface and usability. Line-based, terminal-only editors. You typed commands to edit text. No live preview or cursor movement.
So I guess in 2025 we have
Live preview.
and we also have,
Cursor movement.
so I guess things have, I mean, that greatly increases productivity and saves time when programming. If you have a cursor to move on the screen. That's I guess that's a big thing. So that was back then.
Full graphical interfaces. Eyes.
So today, in 2025, we have a...
Full graphical interfaces. GUIs.
Could you believe that? We have a display that can show us a text, just like back in...
1971.
I mean, I don't know what the difference is, but we also have, in 2025,
Mouse support.
we do have mouse support. We also, in 2025, we have a tab key. Oh no, we have tabs. We can have multiple text documents open at the same time. That's very useful.
Tabs.
And we have syntax highlighting. That's also very useful, you know? I don't know.
Syntax highlighting.
And we have auto completion. That's like actually the most useless, most annoying thing when you're trying to fucking type and it just adds characters. Anybody that types with auto completion isn't really typing.
Auto completion.
What the fuck is real-time feedback?
Real-time feedback.
What does that mean? With text editing. Oh, you get syntax highlighting. Again, I guess.
Syntax highlighting. Code folding.
Oh yeah, you can click a button and it'll fold an area, but it won't stay. When you close the program, you open it, you gotta refold all those areas because it can't remember that because it's not part of the text file. It's part of the program. And the program resets. And I don't know, yeah. This is some bullshit. What does this have to do with text editing?
Version control integration Git.
What does GitHub have to...
Plugin systems.
None of this is useful.
Linting and static analysis.
Oh, of course,
I code completion. For example, GitHub Copilot.
man, Microsoft is really paying money for some advertisement. Jeez.
Version control integration Git. GitHub Copilot.
I mean, we got AI saying that AI itself
Capital A. Capital I. I code.
in GitHub and Copilot.
GitHub Copilot.
AI is like, you know what, in 2025, we have AI code. This thing can't code for shit. And then they throw in GitHub and Copilot. How do those make programming any easier? GitHub sold out to Microsoft, and Copilot is run by Microsoft. Microsoft made the Windows Phone. Does anybody even remember the Windows Phone? No? Exactly. What does this mean?
Programming language awareness.
What the fuck does that mean?
Then, editors had no understanding of programming languages.
What, the editor can understand my language that I'm programming in? What does that mean? It like thinks?
Now, modern editors like Versus Code, JetBrains. Now, modern editors like Versus.
Is this like, what is up with the Microsoft promotion? Everything involves Microsoft.
Versus Code. Versus Code.
Why is Microsoft in every fucking thing?
Modern editors like VS JetBrains IDEs, and Atom offer language servers, context-aware suggestions, inline documentation, and refactoring tools. Extensibility and customization. Limited or no customization. Now, editors like Emacs and Vim became famous for being programmable. Modern editors VS Code, Sublime Text, offer plugin architectures and extensive theming.
This is what I mean by modern, right here.
Modern. 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 Modern.
I don't understand what the whole point of,
Modern.
like, why is everybody saying,
Modern.
what's the difference between now and, or then, and
Modern editors.
what makes
VS Code.
Visual Studio so fucking,
Modern.
it's a piece of shit.
Modern. 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 Platform and collaboration. From local to cloud-based. Text editors were once local only. Now,
Huh? The cloud has nothing to do with the text editor. That's storage. That's files. That's folders. That's nothing at all to do with the text editor. Who the fuck would program on Google Docs? How fucking painful that would be? Nobody uses those features for that. Because it doesn't work.
then, editors were lightweight due to limited hardware.
Now they got tons of hardware. And they don't do shit.
Now, more capable machines allow feature-rich but heavier editors. Some editors balance this with performance. For example,
Performance? I can scroll in any text editor, and the screen will fucking tear like a bitch. They can render games in 3D, but they can't render text.
API integration.
Of course AI is gonna throw itself in here. Okay, I'm done. This is a waste of time. This is what I mean by they. When I say those people or them, they keep saying modern right here.
Modern. Modern. Modern editors. Modern editors.
If I go to visualstudio.com, I might find the word modern. I can't waste any more time, so I'm done. So I won't go to visualstudio.com. I won't. I'm gonna stay on track today. Oh, nothing's working. I'm gonna take a break and I'll be back. I'll get Siri reading and I'll start up this computer first.
Modern editors. It is a syntax error if initializer is present and initializer contains supercall is true. Class element name, private identifier. It is a syntax error if string value of private identifier is constructor. Class static block body, Class static block statement list. It is a syntax error if the lexically declared names of class static block statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of class static block statement list also occurs in the var declared names of class static block statement list. It is a syntax error if contains duplicate labels of class static block statement list with argument is true. It is a syntax error if contains undefined break target of class static block statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of class static block statement list with arguments and is true. It is a syntax error if contains arguments of class static block statement list is true. It is a syntax error if class static block statement list.
What a wonderful day to be programming on the modern operating system.
5, 7, 2 static semantics, class element kind.
There's nothing more modern than the blue screen of death. Especially how they update it with the little brown face. Because there's nothing more disgruntling
Constructor.
than finding out you received a blue screen of death on the modern operating system.
Static field definition. Return non-constructor method.
Modern.
Class element. Return empty. 5, 7.
There's nothing more modern than making a file path out of text characters
Arguments and returns a class element.
that relates to some location on some drive identified by a letter.
It is constructor.
It's not a link, it's not a path, it's not a node. It's a symbolic reference to some place anywhere, could be, who knows, till the operating system touches that location and tries to find what you're looking for.
Class element kind.
Nothing more modern than that.
Return empty. 5, 7.
It's like a reach, would reach. Modern.
No arguments and returns a boolean. It is defined piecewise over the following productions. Class element. Method definition. Return false. Class element. Static method definition. Return true. Class element. Field definition. Return false. Class element. Static field definition.
I had a point to make. It was kind of funny. I just lost it. Dang it.
Static semantics. Non-constructor elements. The syntax-directed operation non-constructor elements takes no arguments and returns a list of class element parse nodes. It is defined piecewise over the following productions. Class element.
Oh yeah, this, okay.
It is non-constructor method. Then a return class element.
The RAM usage.
List. Class element list class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method.
Right now the computer's using 4 gigs of RAM. There's 32 gigs of RAM available.
Definition named constructor and that it is not an accessor property or
I open up the folder directory, the files, whatever.
5.
I go to the C drive. The RAM usage stays at 4.7 gigs, whatever it's at. When I click on these drives, the RAM usage should go up. The OS should say, you may be accessing things on this drive, but instead, click on something, and every time you click on something, there's that annoying lag where it's like, oh, I gotta find on the drive the folder you're clicking on because I didn't save it in advance. I mean, you have like fucking 32 gigs on the modern operating system, the modern hardware that runs this operating system. And even though you have 32 gigs, this is a 15-year-old computer. Even with 32 gigs, the modern operating system is unable to optimize opening a folder or a file or anything. The modern operating system does jack shit. It's literally 1970s. What's the point of having this much RAM? You use it, and when you play a video game, that video game gets a limited memory usage. The operating system controls all of it. Nothing gets full performance. I don't know, everything's fucking stupid. None of this is modern. So I'm gonna stop complaining. I'm gonna work on my modern JavaScript engine implementation. In a second, get some water. I'm gonna get some modern water. What does that mean? I don't know, but it's modern. Anything can be modern, I guess.
It identifies
Within context.
class body, class element list. 2. Let new names be the list concatenation of names and private bound all private identifiers valid of class element list with argument new names. 46. ECMA International 2, 024. Relational expression. Private identifier in shift expression.
Start Visual Studio.
Argument names. Return false. 5, 7, 8. Static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initial is a rock.
Okay, so my JavaScript engine, whatever. I had paging. This was originally for 32-bit. This was limited to 4 gigs of RAM. So I paged, and I spent a year optimizing that, and I got it really fast. Where I'd like cache pieces of memory and then right back to the disk. But I had a Samsung solid state
Element name. Function body. Set class element name.
last month or whatever.
Function body.
I was using it for like 2-3 weeks, probably a month. One of these.
Element name. Unique formal parameters.
So it's like a month old, whatever. And then it died. I mean, it died. Like it died. Like it died. What was on it? I lost it. Luckily, it was only a backup drive, so I had the stuff on the other drive. But I need to back up stuff again because I don't have this backup drive. And then I had another drive like this, not this exact model, from a couple years ago, and that one died too. And that had like college backups or whatever on it. So it didn't really matter. These hard drives suck. So, when I set up this new computer to start this whole JavaScript engine thing, pulling up the old project, I had a hard drive like this one. Like 7 years ago, whatever. Man, these hard drives have been around for a long time. Probably wasn't this exact model. They all look the same. Samsung, whatever, solid state. And I saved the timing of the program. And now, the hard drive access, my paging, and my program, it's whack. The times are like way off. And I thought it was a program. What? That was just so annoying. So I got this hard drive because I'm like I don't trust Samsung. So I'm gonna trust whatever this brand is, because I've had a couple flash drives like this brand. They weren't the fastest, but I thought, I'm gonna go for it. It was a mistake. This drive sucks balls. So I spent, I don't know, all yesterday going back and forth. I'm gonna rip out the paging part of my program, because I realize that people might not have the fastest hard drives, and this hard drive has a it's chatbot again. It has a 3D NAND cache, whatever the fuck they want to call it, or DRAM. And this drive has no DRAM, dynamic buffer or whatever, before it writes the memory. And that dynamic buffer makes a huge difference in speed. Because when I run my program on this hard drive, I program caches or whatever, and then it only writes to the drive at certain points. But those files and stuff, they're actually accessed more frequently. So like, this hard drive actually has the opportunity to use that cache to hold it and then stall and then write when it's not using that file anymore or folder. But this drive, it doesn't have that feature because it doesn't have a DRAM cache or whatever. It probably has a very small one, but not a large enough cache to like advertise it like Samsung does. So after realizing that, I don't know, I'm not going to rely on the hard drive for storing data, because this is 64-bit quote computing. So I'm going to use all the RAM, whatever. I'm not gonna play games with storing data from the JavaScript engine to the hard drive and loading it back in, because anyone with a drive that's like this, that doesn't have the cache buffer before the main memory stores, there's like it's wonky. So I'm just gonna rely on the RAM or whatever for storing the JavaScript engine as it's running. And then like, I don't know. And then this standard chatbot said that file access and reads writes are not part of the standard. So I'm not gonna bother to throw that in, since it's not part of it anyways. It's chatbot. I need some water. The difference between these two drives, whatever again.
Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let formal parameters be an instance of the production formal parameters. Empty. Let body function be ordinary function create. Percent function prototype percent. Source text. Formal parameters. Class static block body. Non-lexical this. Lex. Private env before make method. Body function. Home object. Return the class static block definition record. Body function. Note the function body function is never directly accessible to ECMAScript code. The 15th of July 2012 runtime semantics. Evaluate class static blow. CK body. The syntax directed operation evaluate class static block body takes argument function object, an ECMAScript function object, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the file.
Here's a chatbot here. The difference between the two drives, whatever. Why does it have the tilde. It's 535.
A capital D E F I N I.
I don't know. The Samsung apparently writes 560 megabytes per second. Or reads and writes at 530. When it's sequential. This drive, the cheap one that I got, because I didn't want a Samsung, because Samsung failed. It's only 535 megabytes a second and 500 write speed. Now that's sequential. We access files. It's not sequential. So this is like best case scenario with the drive. That's why they don't put random read-write access speed, because it's way different. And the Samsung here is gonna it gets way better random read-write access because it has DRAM. This one has no DRAM. So this drive that I have, I'm gonna keep it. I'm just gonna deal with it because realistically, there are people who have hard drives that are this bad. So if I write my JavaScript engine and it's able to run on a drive this shitty and still get better performance than the modern JavaScript implementation, I need some water, then I'm doing pretty good, and it means that my JavaScript engine will run faster on the better computers with better hard drives. And this is the Samsung, whatever is faster. Yes, it's a lot faster. I would not buy this drive. Never again. So from now on, I'm just gonna stick to buying these, even though they apparently fail after a month of having them, which is really frustrating. I'm actually gonna start backing things up to CDs. Rewritable CDs. It takes so long to write to a CD, but it actually seems more secure. So I'm gonna make a backup later today after I get some stuff running. I gotta rip out the paging from my
instance
from the JavaScript engine, but first I got it running in malloc mode. It's a lot faster. It's like the speed it's supposed to be. The speed is expecting close to, but I have this drive, so when I'm using paging or whatever with the JavaScript engine, the speeds are nowhere near close to what the performance was when I was using this drive. And chatbot said, I don't know, just go real quick.
Environment env. If class binding is not undefined, then a perform class env create immutable binding. Class binding true. Let outer private environment be the running execution.
Is it ECMA or EMCA? I don't know.
Be new private environment. Outer private environment. If class body is present, then a for each string dn of the private bound identifiers of class body. Do I have class private environment contains a private name pn such that pn is dn. Then assert. This is only possible for getter setter pairs too. Else, let name be a new private name whose is dn. Append name to class private environment. If class heritage is not present, then a let protoparent be percent object prototype percent. Be let constructor parent be percent function prototype percent. Else 50 ECMA in 2024 AB.
Okay, so chatbot says,
Text's lexical environment to class CNV. Note, the running execute.
I asked this, whatever.
Is file read write part of the ECMA 262 STD?
And chatbot says,
No, file read write is not part of the ECMA 262 standard.
okay, so because of that, I'm not going to use paging for my JavaScript engine. I'm just going to rip it all out. Because it's 64-bit computing anyways. And it's not part of the standard. I was going to like use like the paging mechanism I have for like just a normal file access, because it was like slightly faster than the C++ runtime for files and stuff. It wasn't much faster, but it was like a little bit faster. It was like basically the same speed. The C++, the file access handlers, wrappers, whatever, object, it's actually pretty good with performance. Lots of stuff in C++ is terrible, but the file access, the reads writes with C++ is actually pretty good. I beat it by like a teeny bit, but not really. It's like the same. So, I didn't make a big advancement with accessing the hard drive itself, because it sucks trying to cache that shit. So, instead of like using my stuff, because it's not much faster than C++ anyways, that part at least, I'm just gonna rip it out, and then I'll link to or whoever uses this engine, they can link to the C++ library for file handling and stuff. So I guess this is what the ECMA whatever is, what chatbot says.
What is ECMA 262? ECMA 262 defines the ECMAScript language, which is the core specification behind JavaScript. It includes language syntax, types, operators, objects, for example, object, array, function, etc. Control flow.
Is that how etc. is spelled? I guess I was spelling it the right way. I need to start spelling it the wrong way.
Control flow, error handling, and other core behaviors. But it does not define any I/O capabilities, including file system access. Where is file I/O defined? File reading writing is handled by host environments, not ECMAScript itself. Examples: browsers, limited support, for example, File API, File System Access API, and access is sandboxed and user permissioned.
So, I'm not gonna do any file stuff, because it's a pain anyways. If I keep the whole JavaScript engine RAM driven, all I gotta deal with is pointers, idenness, like little ident, big ident. I don't know. There's not that many funky 64-bit architectures, and if there are, C probably handles it. And if not, I can say well, it's a C language problem. It's not mine. I didn't write the compiler. I just wrote the JavaScript engine that runs in the compiler. It's not my fault because it is. I don't know. That's the excuse everyone else uses in modern programming on the modern operating system, because everything's just so damn modern in the year 2025. Super modern.
Modern. Modern. Modern.
So I'm gonna give Siri some text to read. And then I will get back to working on my modern JavaScript engine implementation. I'm gonna drink some water because I can't even talk. My mouth is so dry. I'm trying to talk. My lips are just like sticking together. I gotta focus. So I'm gonna like just rip stuff out of my program. I'm gonna bitch. I'm gonna complain. I'm gonna whine. This is like real programming. Everything's at stake here. This is the fastest JavaScript implementation. It is so fucking fast. I just want to run this test code here to be like 100% certain, because I haven't run crap code. So when I run this crap code and the output says it's faster, I'm gonna be like, that's the shit. I'm good. Okay. Because I ran small tests and whatever. I ran like integer versus integer, string versus string, object versus key creation, access. It's all faster, but I haven't run a crap test where like makes an object that's destroyed every 200,000. I need some water. Every certain iterations, and it just wastes an object. I haven't tried code like that, so when I try code like that, if it's faster, it should be faster. I'll be like, okay, I'm good. So this is like real-time programming. Everything's at stake. I spent a year writing a separate memory manager. I kind of had a feeling I closed it. Dang it. So not this drive, the other drive that I got. It's really slow. I had a feeling that I would have to get rid of the paging anyways in the slow hard drive, not this, the one that's really slow that I got. It made me realize I have to remove the paging. I only wanted to keep it for nostalgia reasons, because I spent a year writing it. A year is a long time. But I'm gonna just let it go because it's slower to page things to drive. 64-bit doesn't have a 4 gig limit, so I don't need paging now. So I'm gonna just take it out. And I don't know. This sucks. But the program I spent a year writing to plan to ever add to this program. I'm going to replace the paging with that program so I can have a sparse array support, and so I can support all the other random freaking bullshit in this wonderful, golden, beautiful standard. And I will show like how fast the modern JavaScript implementation. I need water. My words just, I can't talk. So like the current JavaScript modern implementations, I don't know. They're not modern. So like, I'll set an example of what modern means. I'm gonna like meet this 800 page standard. And I don't know. It'd be like super modern. Even with all this shit, it'll still be modern. I want to say something else, but I'm gonna like swear. I should probably stop swearing so much. So I'm gonna take a break. I'll be back. I'm not gonna say it. I'm gonna shut up.
An implementation must report most errors at the time the relevant ECMAScript language construct is evaluated. An early error is an error that can be detected and reported prior to the evaluation of any construct in the script containing the error. The presence of an early error prevents the evaluation of the construct. An implementation must report early errors in a script as part of parsing that script in parsescript. Early errors in a module are reported at the point when the module would be evaluated and the module is never initialized. Early errors in 02, copyright sign, ECMA International 2024, eval code are reported at the time eval is called and prevent evaluation of the eval code. All errors that are not early errors are runtime errors. An implementation must report as an early error any occurrence of a condition that is listed in a static semantics early errors subclause of this specification. An implementation shall not treat other kinds of errors as early errors even if the compiler can prove that a construct cannot execute without error under any circumstances. An implementation may issue an early warning in such a case, but it should not report the error until the relevant construct is actually executed. An implementation shall report all errors as specified, except for the following. Except as restricted in 17.1. A host or implementation may extend script syntax, module syntax, and regular expression pattern or flag syntax. To permit this, all operations, such as calling eval, using a regular expression literal, or using the function or regexp constructor, that are allowed to throw syntax error are permitted to exhibit host defined behavior instead of throwing syntax error when they encounter a host-defined extension to the script syntax or regular expression pattern or flag syntax. Except as restricted in 17.1, a host or implementation may provide additional types, values, objects, properties, and functions beyond those described in this specification. This may cause constructs, such as looking up a variable in the global scope, to have host-defined behavior instead of throwing an error, such as reference error. 7.1 Forbidden extensions. An implementation must not extend this specification in the following ways. ECMAScript function objects defined using syntactic constructors in strict mode code must not be created with own properties named caller or arguments. Such own properties also must not be created for function objects defined using an arrow function, method definition, generator declaration, generator expression, async generator declaration, async generator expression, class declaration, class expression, async function declaration, async function expression, or async arrow function regardless of whether the definition is contained in strict mode code. Built-in functions, strict functions created using the function constructor, generator functions created using the generator constructor, async functions created using the async function constructor, and functions created using the bind method also must not be created with such own properties. If an implementation extends any function object with a known property named caller, the value of that property, as observed using, must not be a strict function object. If it is an accessor property, the function that is the value of the properties, neither mapped nor unmapped arguments objects may be created with a known property named caller. The behavior of built-in methods which are specified in ECMA 402, such as those named to locale string, must not be extended except as specified in ECMA 402. The regexp pattern grammars in 2.2, 1 and b 1.2 must not be extended to recognize any of the source characters at Z or raise Z as identity escape, plus Unicode mode, when the Unicode mode grammar parameter is present. The syntactic grammar must not be extended in any manner that allows the token to immediately follow source text that is matched by the binding identifier non-terminal symbol. When processing strict mode code, an implementation must not relax the early error rules of 1.2.9. 3.1. Template escape sequence must not be extended to include legacy octal escape sequence or non-octal decimal escape sequence as defined in 1.2.9.4. When processing strict mode code, the extensions defined in B 3.1, B 3.2, B 3.3, and B 3.5 must not be supported. When parsing for the module goal symbol, the lexical grammar extensions defined in B 1.1 must not be supported. Import call must not be extended. ECMA International 2024 403 18 ECMAScript standard built-in objects. There are certain built-in objects available whenever an ECMAScript script or module begins execution. 1. The global object is part of the global environment of the executing program. Others are accessible as initial properties of the global object or indirectly as properties of accessible built-in objects. Unless specified otherwise, a built-in object that is callable as a function is a built-in function object with the character.
Something as chap or whatever. What are the layers of the modern JavaScript engine? Okay, here's what Chaplet says.
A modern JavaScript engine, like V8, SpiderMonkey, a modern JavaScript engine, like V8, SpiderMonkey, or JavaScript Core, is a sophisticated, layered system designed for high performance. Here's a breakdown of its typical layers, from source code to machine code execution. High performance. High performance. High performance. High performance. High performance. High performance. High performance.
Within context. High performance.
One. Parser, frontend, input, JavaScript source code, text, output, abstract syntax tree, ast, function, parses and tokenizes source code into an internal structure, ast, for analysis, component, Lexa plus parser.
And then there's the next step.
Two. Interpreter, input, ast or bytecode, output, bytecode, in some engines, or directly executes, function, quickly starts executing code. Warm-up phase, while profiling it for optimization opportunities. Example, V8 uses ignition as its interpreter. Three, profiler monitor. Input, runtime data from interpreter. Function, watches function calls, loops, types, and execution frequency to identify hot code. Frequently run or performance critical. Purpose, feeds data to the JIT compiler to optimize performance critical paths.
Now this is the slowest part of the JavaScript engine. If you rip this part out, kind of like how I'm like ripping out the paging from my engine, because I'm like, it's not worth it. Because 64-bit has 64-bit addressing. There's no reason to keep the paging. I'll just use C++ for file accesses. But if you rip out the JIT compiler from the JavaScript engine, then you get modern performance. This is legit, whatever, I don't know.
4. Baseline JIT compiler. Input, profiled bytecode. Output, optimized machine code. Function, translates hot JavaScript functions into machine code for faster execution. Examples, V8, uses turbofan for optimized compilation. SpiderMonkey, uses IronMonkey, being replaced by Warp.
Now if you notice the wording in this this promotion for JavaScript. Okay. Do you see what this word right here?
Optimize.
And then this word right here.
Optimize.
And then this word right here.
Optimize.
I guess they don't optimize at the parser level, layer, whatever. But you would think with all of this
profiling it for optimization. Identify hot code. To optimize performance critical paths. Translates hot JavaScript function. Optimized machine code. Our faster execution. Uses turbofan for optimized compilation.
So, the fact that they throw the word optimize for steps for layers 4, 3, and 2, it really hints that, I don't know. It seems weird that optimizing at layers 2, 3, and 4, when optimization is the main point of that layer to do something, is to speed something up, make it faster, to optimize it. I don't know. How could you optimize something so much that at the end it still performs slower than a C program? It says tight numeric loops. The speed difference between C and JavaScript. JavaScript has those 4 layers, 3 layers, whatever. They optimize, okay? With all this optimization, all of it, it's still slower. And by how much, whatever? Oh, let's see. Here's what Chatbot says. Chatbot's like wrong a lot of stuff. It pulls up the wrong data and just prints it. But assuming something here is right, something will be right. I don't know. It's just as accurate as a Google search.
Typical performance gap. C versus JavaScript. Tight numeric loops 10-30 PROLOGUE has direct access to memory and types. JS has dynamic typing. 10-30. Slower.
So, with all that optimizing, numeric loops are 10 to 30 times slower. Huh.
String manipulation 2-10 slower. JS can be fairly efficient here.
It's because they're using butthole strings. Anybody that uses standard C strings is an idiot. This is misleading. This right here. String manipulation, that's bullshit. Everything, realistically, is 10 to 30 times slower. If not more. Okay, so this makes sense. If it would highlight.
Heavy array computations 5-20 slower typed arrays in JS help narrow the gap. 5-20 slower. 10-30 slower. Why is JavaScript slower? Dynamic typing. Variables can change types, so engines must garbage collection. C uses manual memory management. JS uses garbage collection, which can abstractions and safety. JS lacks direct memory access and pointer arithmetic, limiting low-level optimizations. IT versus AOT compilation. C is JIT versus AOT compilation. C is compiled ahead of time to optimize native code. JS uses just-in-time compilation, which introduces startup overhead.
Oh, here with the word modern again.
JavaScript is slower than C, but the performance
A lot slower.
engines and tools like WebAssembly. Modern JIT. Modern JIT. Modern JIT. Modern JIT. Modern JIT.
And even the modern JIT with all this
Translates hot JavaScript functions into machine code for faster execution. Uses turbofan for optimized compilation. 4. Baseline JIT compiler. Modern JIT. (10, 30) slower. C has direct access to memory and types. JS has dynamic typing.
Okay, so I don't know. If you rip out all this shit, there's more layers, like the garbage collector and the runtime execution.
allows precompiled bytecode. For example, V8's code caching to speed up repeated loads.
I don't know if they're caching to the hard drive. That's what I was trying to do. If that's what they're doing, it's very slow. That's why I'm not going to use caching on the hard drive. I don't know. There's way too many layers for the modern JavaScript implementation. If someone were to go through this standard and follow it without all the bullshit of this JIT compiler and overly complicated stuff, because they don't know how to program, so they use virtualized code to account for their lack of knowledge. I don't know. It's gonna be a lot faster.
How long would it take to make a JS engine that runs in C-language instead of JIT?
And Chepet says,
Building a JavaScript engine in C without JIT is a significant project, but it's doable, especially if you're targeting interpreted execution only, no JIT. The development time depends on hammer and spanner. Key factors 1. Scope. Are you building a fully spec-compliant ECMA 262 engine like V8?
yes, I am.
Basic arithmetic, objects, functions, something embedded, like for microcontrollers, for example, duct tape. Team size and experience. Are you working solo or with a team of systems programmers?
It's a one-man show. Well, not totally. Okay, maybe a three-man show.
Standards compliance. How closely will it follow the ECMA 262 spec, which is 800 plus pages?
Google doesn't even meet the fucking spec. I'm gonna meet it 100%. With no, without zero.
And could leak memory resources in implementations.
So I'm gonna meet the standard without
And could leak memory resources in implementations.
like some implementations happen to do apparently.
Features required will you include garbage collection, closures, async await, eval, proxies, etc. Built-in objects like array, promise, date, etc.
Well, duh, that's in the standard. This, it seems like chatbot's trying to like discourage someone from doing this. They're like, oh, it's a lot of work. Are you sure? Are you gonna do all of it? Would you do garbage collection? There's also closures. There's async. There's await. There's eval. There's properties, etc. There's built-in objects. It's like it's a. I don't know. It's a little weird how it's answering this question. Oh, the chatbot like has an answer. Let's see what it says. I'll like actually focus after this.
realistic time estimates. Minimal JS subset basic syntax, expressions, functions, no GC1-3 months. Lightweight engine, like duct tape, interpreted, basic spec compliance, GC, minimal built-ins. 6-12 months. Full ECMAScript 2023 compliance fully featured, browser grade 2-5 years plus, team effort.
I don't know, times are pretty close. But 2 to 5 years, that's just a generic that everyone plans to have some kind of project done. Okay. This is misleading.
Examples of JS engines in C. Duct tape C small, embeddable, Node.js, interprets JS. Mudge very small, supports CS5 features. ECMAScript C designed for low memory devices, for example, IOT. QuickJS C surprisingly complete, includes ES 2020 plus support. Written in.
So, it's already misleading. These are written in C. It doesn't mean they run JavaScript as C.
Tip: if your goal is to learn or prototype, start small, perhaps with an interpreter for a limited subset, numbers, strings, variables, if while, functions. This avoids the massive complexity of full JavaScript, especially things like this: hoisting, async, etc. Dart. Would you like a basic plan or architecture?
I guess I'm gonna focus, whatever. I forgot what my point was. Other than the current modern JavaScript implementation, it sucks. So I'm gonna like try to find entry point for me to put this crap speed test function. I'm gonna run it, compare it to Chrome, and see the speed difference. And then I'm going to save it back up. And I have to using the malloc mode where it uses RAM instead of hard drive. I have to turn on all the files that were in use for the hard drive mode off, hit build, figure out only the files that are used, and then I need to remove everything that's that involves paging to the drive, because I need it out. All I need is the malloc files that use malloc, that use RAM. And then I can go through and get the rest of the unsigned, signed, and int types. I have new files now that are included for the malloc mode that weren't used for the paging mode. need to think. For now, I just want to get this test running. So I gotta try to find an entry point, and it builds now, whatever, in a minute, 30 seconds. So it saves me 30 seconds each build if I don't use paging, because those files added a lot of stuff for the compiler to do. So I'm gonna get this test function running. I'll get like the actual speed now because there's no hard drive bullshit involved. And I don't have to worry about modifying the program as it is. With paging, I can just, if it's out, it's out, and it's not even in there for me to deal with. So it makes updating the engine easier. There's a couple other things I want to rip out too that aren't really needed then. I gotta attach the other program. Okay, first I'm just gonna find an entry point to call this test function because it does build. I'll hit build again really quick. Save it back up first. This hard drive is slow, really slow. Okay, it's building. I'm gonna let it build. I'll run it just to check again, because maybe it didn't work yesterday. This compiler is spotty. Sometimes it works, sometimes it doesn't.
The 7th of January 2013 to big int. Argument. The abstract operation to big int takes argument in ECMAScript language value and returns either a normal
This will take a minute to finish building.
to a big int value, or throws if an implicit conversion from number would be required. It performs the following steps when called. Let them be.
Whenever it's done building, I'm gonna come back. I'm gonna just... Oh, it's done. Dang it. I'll be back anyways. I gotta like find an entry point. I'm gonna call the test function, whatever. Speed test it. I don't know, I'm gonna come back. I'll sit down. I'm not gonna talk. I gotta focus. I gotta like actually find an entry point to like call the test function. after that speed test, I'll know whatever that it's faster, it is faster. Just, I want to check with the timing of it compared to Chrome. Then, I'm going to save a backup of this whole thing before I rip out the paging. I kind of want the paging. I could like modify it for other data structures, but it adds overhead. So I'm gonna focus on getting the stupid test function running, get the speed, save it back up. Then from that point, I'll figure out what to do. I think I'm gonna have to rip out the paging mechanism and some other stuff, and I gotta figure out which files are only being used when I rip out the paging. I'll have other files now to update the int and stuff to use keyword.
From
Oh.
int 64-bit BR n modulo 264 if int 6
I don't know, when I get back, I'm gonna get it to call the test function. That's my first goal. And then I gotta figure out a lot of stuff.
and argument in ECMAScript language value and returns either a normal completion containing a big int or a throw completion. It converts argument to one of 264 big int values in the inclusive interval from 0z to z, 264 1. It performs the following steps when called. Let n be to big int argument. Let int 64-bit br n modulo 264 return z int 64-bit, 1.17 to string argument. The abstract operation to string takes argument in ECMAScript language value and returns either a normal completion containing a string or a throw completion. It converts argument to a value of type string. It performs the following G steps when called. If argument is a string, return argument. If argument is a symbol, throw a type error exception. If argument is undefined, return undefined. If argument is null, return null. If argument is true, return true. If argument is false, return false. If argument is a number, return number. To string argument 10. If argument is a big int, return big int. To string argument 10. Assert argument is an object 0. Let prim value be. To primitive argument string 1. Assert prim value is not an object 2. Return to string prim value, 1.18 to object argument. The abstract operation to object takes argument in ECMAScript language value and returns either a normal completion containing an object or a throw completion. It converts argument to a value of type object according to table 13. 0. Copyright sign ECMA International 2024. Table 13. To object conversions. Argument type result undefined. Throw a type error exception null. Throw a type error exception boolean. Return a new boolean object whose internal slot is set to argument. See 20.3 for a description of boolean objects. Number. Return a new number object whose internal slot is set to argument. See 21.1 for a description of number objects. String. Return a new string object whose internal slot is set to argument. See 22.1 for a description of string objects. Symbol. Return a new symbol object whose internal slot is set to argument. See 20.4 for a description of symbol objects. Big int. Return a new big int object whose internal slot is set to argument. See 21.2 for a description of big int objects. Object. Return argument. The 7th of January 2019 to property key. Argument. The abstract operation to property key takes argument in ECMAScript language value and returns either a normal completion containing a property key or a throw completion. It converts the argument to a value that can be used as a property key. It performs the following steps when called. Let key be to primitive argument string if key is a symbol, then a return key return to string key, 1.20 to length argument. The abstract operation to length takes argument an ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It clamps and truncates the argument to an integral number suitable for use as the length of an array-like object. It performs the following steps when called. Let len be to an integer or infinity argument. If len 0, return +0, return min len 253 1.21 canonical numeric index string argument. The abstract operation canonical numeric index string takes argument a string and returns a number or undefined. If argument is either -0 or exactly matches the result of toString n for some number value n, it returns the respective number value. Otherwise, it returns undefined. It performs the following steps when called. If argument is -0, return -0. Let n be to number argument. If to string n is argument, return n, return undefined. ECMA International 2024-71. A canonical numeric string is any string value for which the canonical numeric index string abstract operation does not return undefined. 1.22 to int x value. The abstract operation to index takes argument value, an ECMAScript language value, and returns either a normal completion containing a non-negative integer or a throw completion. It converts value to an integer and returns that integer if it is non-negative and corresponds with an integer index. Otherwise, it throws an exception. It performs the following steps when called. Let integer be to an integer or infinity value. If integer is not in the inclusive interval from 0 to 253 throw a range error exception. Return integer. Point 2 testing and comparison operations. 2.1 require object coercible argument. The abstract operation require object coercible takes argument an ECMAScript language value and returns either a normal completion containing an ECMAScript language value or a throw completion. It throws an error if argument is a value that cannot be converted to an object using toObject. It is defined by Table 14. Table 14. Require object coercible results. Argument type result undefined. Throw type error exception null. Throw type error exception boolean. Return argument number. Return argument string. Return argument symbol. Return argument big int. Return argument object. Return argument 7 2 2 is array argument. The abstract operation is array takes argument an ECMAScript language value and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. If argument is an array exotic object, return true. If argument is a proxy exotic object, then a perform. Validate non-revoke proxy argument. B let proxy target be argument. C return is array proxy target. Return false. 2. ECMA International 2024. 7 2 3 is callable argument. The abstract operation is callable takes argument an ECMAScript language value and returns a boolean. It determines if argument is a callable function with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true. Return false. 2.4 is constructor argument. The abstract operation is constructor takes argument.
I'm not like coding for fun. I'm coding for winner takes all. So I don't know. People like, I program. And they have like a to-do list and they like follow it top to bottom. And there's other people that do program and they're able to do a to-do list top to bottom. And if you're doing programming, and if you like do the same kind of programming, like making a video game, it's easier to do time management because you have more specific things. But when you're making something that hasn't been made before, there's a whole lot of decisions. Every decision includes time, and I'm stuck. I was going to rely on the paging as a crutch to like throw in my new program that I wrote for memory managing and garbage collection that took a year.
The abstract operation is regexp.
I'm gonna use the malloc calls. That's just a normal malloc. The normal RAM call, whatever.
Return false. Let match be. Get.
I can't garbage collect that without a wrapper to hold the allocation,
473.
and they end up with a pointer to a location, or a pointer that holds a pointer, or a pointer that points to another pointer, and each holds a location. Either way,
And returns a boot.
at some point, that memory needs to be recycled and reused so it doesn't just get uncollected and sit waiting for something to be released next to it in the memory and unavailable until those things just happen to be released because you don't know when something will be released.
UTFs.
Because you can have a pointer to a pointer to a pointer to a pointer, but at some point it points to a finite location in memory, and if the implementation isn't able to physically remap that memory to any other location in memory, it is impossible for that memory to be reclaimed next to memory next to it, depending on the implementation. So, using paging, it gives me the benefit of having like working RAM and then separate pages, and I can swap around the pages because the working memory is working memory, which is like static whatever. So I could like make a static segment BSS size allocation whatever of how much RAM on your computer. So I have 32 gigs, I could just make it 32 gigs. It's all virtualized anyways, as like a base. And then use that as like the assumed working RAM. Or make it half the size of the RAM.
Number. Same value 0, x, y3. Return same value not.
And then that would be the memory that's like always in use. Like a bucket of water that isn't possible to be remapped because it's always used. Then the overflow, so if you use over that memory, that goes to the page, and the page can go to a separate structure that could be remapped, that could be put to the hard drive, that could be loaded from the hard drive.
And then a return.
So there's like working memory that's like maybe 16 gigs of your RAM. Super fast access. It doesn't ever have to be garbage collected. Holds a bunch of little pieces, fragments of memory to other fragments. They all get collected. They only get stored, read, written, all managed super fast. So if I replace the paging, like the physical paging to the file calls to use my new memory manager, I don't have to do any like real work. All I have to do
Return true. Otherwise,
is find where it calls file, open, read, write, seek, and replace that like with JC file, whatever, open, read, write, verb, and then seek, whatever. But then behind the scenes, it doesn't go to a file, it goes to my memory manager.
Returning true, false.
But there's like a slight overhead. It's not slight, it's quite a bit. It's enough to make me think it's not worth it. But if I use the malloc mode with that uses a RAM, if I use my new memory allocator thing instead, I get another teeny slowdown, which could end up being a big slowdown, because every access is gonna incur accessing a full data tree every time it's accessed. So either I bet on using like a bucket of memory that's fixed size and it's all tagged and managed carefully. So like when you access the data tree, whatever, maybe I should just rip out the paging. Like when it's cached, it's right there. It's in like a little slice of memory. It just gets passed around until it's like done with, and it gets tossed off and stored back. And caching works. And it makes it simpler to pass around values. I don't know what to decide. I had to fucking test it. Fuck. So. I can't plan any of this because I don't know till I do it. But I need some water. And I think I'm gonna have to keep the paging mode, all of it, for now. I'm gonna have to update the types, whatever. The unsigned int and the signed int and the int across whatever files I have open or like I included. So I'm gonna have to do extra work to update all the files that I'm using that I might not use in case I need to use them.
X, Y, J.
Because I started updating everything to support paging, so I might as well finish it, but also update the files that I use for the cache only mode or the RAM only mode. That way, and then I have to update the 64-bit arithmetic too, but for the malloc mode, the RAM mode, and the caching mode.
Equal according to.
That way, when that's all done, that's literally all I need done. I want to do like a browser test to compare, make a little demo with OpenGL, but then I'm going through the ECMA and going through the standard.
This type, Y, then a return is strictly equal x. If x is...
But then both modes will work, and then I can test with my new memory manager if it's more optimal to use to replace malloc. I'm gonna have to find all the pointer accesses. Okay, both ways are going to involve the same amount of work. Okay, so I don't know which one will be faster. It could be the one that uses only working memory, or the one that has to incur cache misses every time when accessing stuff in a sparse data tree. It could go either way. So I need to support both options so I can pick either or. So I'm going to keep the caching for now. The file caching, page caching. I might just make a wrapper, and instead of paging to the hard drive, I'll page to my memory manager, which goes to the RAM. So I get all the extra data structures that were used for paging, but instead of going to the hard drive, it's going to go to the RAM. So it's just like a barrier, so I can separate running memory from memory mapped memory. That way, the garbage collector would always be anything that's paged. Whenever it hits 0 references, I can literally dump it and remap memory around, so like I can drop a slab allocator. I can drop slabs at a time from a larger slab as I remap memory to fill holes until a slab becomes unused, and I can dump it and actually like release memory that's been allocated. Unlike current implementations that are incapable of doing that. But I could also do that too without the paging, but every memory access is going to have extra little penalty for access, but that might actually be faster because it's going to keep things in the cache. So there's like, I don't know, either way could potentially be faster, but it also depends on the RAM, the CPU speed, and the cache size. And maybe one way be faster on older computers compared to newer ones. So I'm gonna have to run this on a newer computer too to make sure. Okay, so overall, I'm not gonna rip anything out yet. I'm gonna update only the malloc mode for RAM and the file paging mode to these types after I do this speed test. I'm gonna do right now after I stop talking. I'm gonna update the types, and then I'll update everything to 64-bit, even though I might have to rip out the caching because I might potentially keep it. And that's how real programming is. Because I don't know what to do until I test it, and I can't test it until it's done. I'm have to spend time accounting for both scenarios. And I don't want to waste time making a little mini test right now, because I have mini tests and they work, but it's not like a real world scenario test, which is why I want to run this crap code test here. That's why I'm going to find an entry point. Wrong screen. I'm going to run this here. This is a real world test. So I want to run a real world test in the malloc mode. I need to find an entry point. I know the paging mode is going to be slower because this hard drive's crap. But if I replace the paging to the hard drive to paging to the RAM, I get the benefit of making memory mapping easier for garbage collection. So I'm going to keep both. There's so much fucking work. I'm going to keep both to save time, and I'll decide later. But for now, I'm going to find an entry point. I'm going to call this. I converted part of it last time, I think. I'll run in browser, I'll run in mine. See the speed difference. That's what I'm doing first. Then I'll deal with getting the rest of the types.
Capital.
And then updating to 64-bit. I'd rather update files, even if I don't use them, in case I use them, rather than remove them and then be like, oh crap, I should have tried this, and then have to pull them up again. So I'm like in a rock and hard place, in a pickle. I'm gonna have to plan for both pickles. Whichever pickle is the sweetest is the pickle I'm gonna pick. It's kind of gay, but it is what it is. So I'm gonna pick. What is it? Peter Piper picks a pickle. Pickle. I don't know. I need to focus and stop talking. I'm gonna find an entry point. I'm gonna have to support both the build modes. Knowing that I'm not gonna do paging, I'm gonna use C++ for file accesses. Because I will admit when I don't have something that's faster. My file access and paging, it's like the same speed as C++. But when something's faster, I'm gonna say one's faster. So, the paging stuff, I'll just use C++ for that. Or like files, not paging. I don't know. I feel like if I repeat myself again and again, I'll make a decision, but I'm not. I can't make a decision. This stuff, you invest so much time. It's like a baby. And if you take it out, you fucking kill it. Nobody likes killing babies. Except for, it's a touchy subject. Abortion clinics, they like killing babies. Because they get paid for it. So, I don't want to kill any babies. All lives matter. I'm gonna get to programming now. I can't make a decision. Either way is gonna suck. It all involves work. But one way will be better than the other. I don't know till I get there. So I'm gonna like find an entry point, run this, see how fast it is, compare it. Then I got two pickles, to account for one that uses RAM. I got a RAM pickle, and then I got a paging pickle. I'm gonna update the paging pickle to use malloc. So that's RAM 2. So I'm a double RAM pickle, but I don't know which one's faster until I attach my memory manager to those pickles. Then I'll have some memory managed RAM pickles. Whichever pickle is the sweetest is the pickle I'm gonna pick. Pickles. Okay, so I'm gonna run this. It should still run. It ran yesterday.
Following steps when called. Let func be jet v p. If func is either undefined or null, return undefined. If is callable, func is false. Throw a type error exception.
Don't compare the logout to the logout from yesterday. I'll find an entry point. Let me drink some water. And then I'll call my or not my this
It performs the following steps when called.
this crap function. I'll find an entry point. It's really tiny. I can't really zoom as soon as I'll find an entry point in this program down here at the bottom.
Return false. Return true.
So after all that stuff, I'll call the crap function, do a speed test, then I'll know
An ECMAScript.
for certain
A list of ECMAScript.
how fast it'll be in scenarios where it's like crap code. I'm gonna have to make more crap code to really get like, but this is enough for now.
479.
Then I'm gonna deal with the RAM pickle and paging pickle business. I don't know. That's about it.
It performs the following steps when called. If arguments listed.
What is this done? Back up, log out.
For exception, return F.
Both log the same number of lines. So I'm pretty sure it's okay. This sucks. So I have to make an entry point right here.
If arguments list is not present, a new empty list is used as its value. If new target is not present, F is used as its value. It performs the following steps when called. If new target.
So when it runs, after all stuff above whatever, right here, I will put my entry point. Well, actually, right here. I'll say here because visually there's more space. I'll put another press continue right here. I'll have entry point right here. And I will be calling this function, whatever.
Properties of an object. It performs the following steps when called. Let status be O. If status is false, return false. Low keys P. O. If level is sealed, then for each element K of keys, do I perform. Define property or throw O. K. Property descriptor false. Else assert level.
I'm going to call this JavaScript function here.
A let desk.
So this, I'm going to insert it.
Find property or throw O. K. Desk 6. Return true, 3.16 test integrity level. Oh, level. The abstract operation test integrity.
At this entry point here. So I have to find where this is at first. That's what I'm going to do. I'm going to turn the mic off. I'm going to stop talking for once. And I'm going to find where to insert it at this entry point. I'm going to run it, see how fast it is compared to Chrome. And then I'm going to save a backup, like a backup.
2024. No.
And I'm going to like continue updating because I have to make progress. I won't make any.
Then, if current desk is true, return false. 2. If level is
So instead of dealing with pickle business, I'm going to
6. Return true, 3.17 create array from list elements.
This is what I said I was going to do like a second ago. So after that, then what I'm going to do is this. Whatever files are used for both pickles, I'm going to get the types replaced, right? After that, I'm going to convert all those files in use to 64-bit addressing. Okay? So then, I will be set up for either pickle. Either scenario, I'll be good. I just want to be good for a double pickling in case it's needed. If I have to pick between one pickle or the other pickle. And then I'll have to deal with the pickle business right here. So, pickle business, that's right here. I'll put that in my to-do notes. So I'm going to finish this stuff here and here. So it's like done. It's off the top of my head. I don't have to worry about it. Then, pickle business. This is where things will get... Are pickles sticky? I don't know. They'll get pickly. Because I have to make like all the decisions, actually test stuff, and I'm gonna have to like kill a pickle baby or not, because I might have to keep one of the pickles. I don't know. If I can get these two things done, then they're done. That's my goal first, is to get these 3 things completed. And at that point, it's like a checkpoint. I can finally move on to other things. Because if I just keep thinking ahead, nothing will get done. And if I start speed testing everything, nothing's done still. I'm just worrying about which one I should pick. So instead of picking a pickle, I'm gonna update both pickles. So everything is what it needs to be. And then I'll pick a pickle. Then I'll be ready for a pickle picking business. And then I can make speed tests. And since it's all updated at that point, I won't have to worry about, well, is this one faster than this? Well, I have to finish this before I can do this, before I can do that. If all this is done, I can do whatever I need to do when it relates to like picking what I'm gonna pick as a final decision. Alright, that's a decision. I've just made a decision. I'm gonna stick with it. And I'm going to do this first. I'm gonna find an entry point so I can call this. I'm gonna check it. I'm gonna get these types done. I have 2 days. Oh my god. 2-day countdown. I'm almost to day 0. See how far I can get. I'm gonna stop overthinking for now and try to just focus and whatever. I don't know. I hate pickles. Well, no, I don't. I like pickles. I'm gonna stop stalling.
If is callable, C is false. Return false. If C has an internal slot, then a let BC be return. Instantia of operator O BC. If O is not an object, return false. A let PB. Get C prototype.
I don't know, I said this last time, whatever. I got like a pen tablet, but it's at a slant on the Mac. It's like a 45-degree angle. I don't know.
Species
It's hard to like look at the main screen.
A constructor and returns either a normal completion containing a constructor or a throw completion. It is used to retrieve the constructor that should be used to create new objects that are derived from a default constructor as the constructor to use if a constructor at species property cannot be found starting from O. It performs the following.
I got like the main screen on, whatever. I got the Mac. I gotta like look down at the pen tablet. It hurts my neck at some point. So I'm like, just leave the browser in the tab. Or in the other one, I don't know. I realized that some of the music videos for some of the songs that are like playing whatever, even when I hit shuffle on YouTube, they're kind of gory. But, I don't know. It is what it is. Just judge me or whatever. So, I'm trying to, like, list.
Performs the following steps when called. Let own keys be. Oh.
I'm gonna, like, listen to music, focus, find a entry point. So I get to pickle business. And the little, pen tablet screen is too small to like use as a display, so I'm using the Mac or whatever. I don't know. I need to stop stalling.
Array from list. Key. Value. 3. Append entry to results. 3.24 get function realm. OBJ. The abstract operation get function realm takes argument OBJ, a function object, and returns either a normal completion containing a realm record or a throw completion. It performs the following steps when called. If OBJ has an internal slot, then a return OBJ. If OBJ is a bound function exotic object, then a let bound target function be OBJ be return. Get function realm, bound target function. If OBJ is a proxy exotic object, then a perform. Validate non-revoke proxy. OBJ be let proxy target be OBJ see return. Get function realm, proxy target. Return the current realm record. 3.25 copy data properties. Target, source, excluded items. The abstract operation copy data properties takes arguments target, an object, source, an ECMAScript language value, and excluded items, a list of property keys, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If source is either undefined or null, return unused. Let from B. To object, source, let keys be from. For each element next key of keys, Do a let excluded be false be for each element of excluded items. Do I have same value e next key is true, then 1. Set excluded to true, see if excluded is false. Then I let desk be from next key 2. If desk is not undefined and desk is true, then let proper value be get from next key perform. Create data property or throw target next key proper value. Return unused. Return results. Note step 4 will only be reached if obj is a non-standard function exotic object that target passed in here is always a new.
I kind of want to make a diagram to show what I mean by like the working memory
2026
and how the paging will work differently.
and P, a private name, and returns a
But I don't want to waste a lot of time
if O contains a private.
because I know I'm stalling. I need to like make progress. So I'm gonna stall for like a very, very tiny amount of time.
And value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs.
Okay, so the malloc mode that doesn't use paging.
Host ensure can add private element. Oh, let entry.
Wow, this computer's laggy. Paint isn't even. Holy shit. I didn't know Paint used so many system resources. Wow.
3.28 private.
This is a struggle.
Method. The abstract operation private method or access.
Oh, it's smoother now.
An object. And method. A private element. And returns either a normal completion.
The lag, holy crap.
It performs the following.
Okay, so the malloc mode. Malloc is
Method.
just a line of memory. If you make an array in JavaScript with like 10 million integers, or you like set a key to 10 million,
Argument O.
you'd have to like make an allocation that big for array access, whatever, to access array 10 million in. So you make a sparse memory type
Requirements. If
so that you can like have like
abstract operation must return normal completion.
a small layer of memory
Rules of this.
that holds like a leaf, and then another leaf, and another leaf. Like that, whatever.
ECMAScript hosts that are web browsers.
So with the normal array, you would access the base address, and then you go to 10 million if there's 10 million in it. If it's like a long array with the data tree, whatever I'll call it, or memory mapping, doesn't matter. You'd enter, you'd access like the first pointer leaf, the second pointer leaf, the third pointer leaf, however many pointer leaves there are to get to the end of it. That way,
The throw completion.
you don't have to waste memory on all the stuff before it. Because you're only storing this far in here. But this has the overhead
Entry is accessor. If
of accessing this layer of memory, this layer of memory, this layer of memory, just to get to this one. So like the normal array access is the base plus the length offset to it, and then the modern operating system is a flat address memory model.
Oh,
So they have a memory manager, the memory managing unit that handles the translation and pages to the drive much faster than file paging. File paging on the modern operating system is absolute shit. there's no reason for the 10 millisecond delay on file access. It's all intentional. The hard drive is very fast at hardware level. With the OS, it's not fast at all. They make you have to use RAM. So, when I switch the whole program from malloc mode, which is like this, whatever.
Field record. If initializer is not empty, then a let init value be. Call initializer.
So this is malloc mode. Not everything is a super large array, but I'm getting there, assuming it is. I would be switching from this kind of access to this kind of access. So every memory access is going to have an extra 1, 2, 3, 4, however many to get to the memory. That'll be slower. So the whole engine, the speed that it is right now. Okay, here's why it matters.
An ECMAScript function object, and returns either a normal completion containing unused or a throw completion. It performs the following steps.
Right now,
for each private element method of methods, do perform private method or accessor add. O method. Let fields be the value of constructor. For each element field record of fields, do a perform.
my engine, whatever. If it's an integer key, I make it an array, which means however large the integer is, that's the top of the array.
Of ECMAScript.
So if I set like an integer of 10 million to an object or an array, if the allocation, the malloc, isn't 10 million large, I have it resize from whatever it was to 10 million, and it sets the 10 millionth whatever in the allocation. Clearly, that's a problem. Not for me, because I was using integers as like just a normal access. I didn't use huge ass numbers. I was treating it like a C program. I only accessed memory that I needed. I didn't like use some arbitrary number for some reason. But JavaScript supports that. So I need a hash map of some sort, which is a map, whatever. Like I said earlier, whatever. So if I add a hash map, for every access, for every allocation, whatever, then I won't have to make an allocation that's 10 million large. I can just access like 3-4 leaves to get to the end here, and that's how I'll store it. So I don't have to waste a whole bunch of memory on holding memory that might not be used. So it means that all of my accesses, and this is only true for like large allocations, if like somehow 10 million integers happen to be used, I would just make a flat allocation like normal, but normally it's not like that. There's a bunch of holes in the memory. So I can get this speed up, this slowdown, doing it this way to support these large allocations. Or
Value used to encapsulate.
I can keep the paging I have,
Table 15.
where instead of if I set something to the 10 millionth in an array like this, whatever, if I want to set something to 10 million at the top of a large allocation, when it's in the paging mode, I save
Object done. A boolean, whether the iterator has been closed.
Like the number 10 million, if this is a 10 million, whatever.
Method.
And I save like what the object is, whatever.
J. Initiate.
And I save it in a cache. Like working memory.
Completion. It performs the following steps.
So if I set something to like 9,000, then I save the tag, and I save what it holds. If I set something to like the array and dice 22, then I set the tag with 22, like that's blue, whatever is 22. Whatever it holds is yellow, so maybe it's a number, a string, and int. If I set something at like 45 in the array, then that goes here. So I make, if I make this paging, whatever, like, if I make this 1/2 of the RAM, so if you have like 32 gigs, and I use half of the RAM like this, then 16 gigs would be used for caching, which means that every access is going to be like looked up or whatever, but I have like the overhead of the lookup to find these cached things might be faster than storing things like this. So like
ECMA International.
both these techniques have the overhead of finding something in memory. It's a memory game. But this technique, I can use half the RAM for this, and I can use the other half for paging. So instead of paging though, I would use the RAM. So instead of going to the RAM, since you can like access more RAM beyond your hard drive space because it pages naturally, this could just keep expanding or whatever. So at some point, there's going to be too many tags, and it has to be put to the upper parts of RAM. And these upper parts of RAM, I can memory map these without having to memory map these. But this mode, the memory mapping would be done at like the lower levels as it's running, which makes it more difficult and possibly slower. Because if there's like a piece of memory here, and like this memory is freed here,
Turn. Get. Iter result. Value, 4.7 iterator step. Iterator record. The abstract operation iterator step take.
like if this is a block of memory, and then I free this memory here. I made it red. I don't know if that's even, you can even tell. If I free this memory, it means that I would take this memory, I would like move it physically to here. And if I free this memory, then whatever's at the end, I would move this memory to here. And if I free this memory here, whatever's at the end, I would remap it, whatever's here to here. So if I continue to do that, anything at the end, if I remap it to the hole that's freed, eventually this entire chunk of memory is not used, and I can free it. So I can remap memory as it's running this way, but having to shuffle around memory as it's running and accessing when if I set it up this way, I can have it running here, whatever. And I could like set up a separate thread even, and have that separate thread handle only remapping. So this could literally run as runtime memory, and this would be remap memory. And then I would attach this into this or whatever. So this as well would replace paging. So I'm trying to decide, and I can't decide between this is pickle 1, this is pickle 2. I don't know which will be better until I test both. Because this pickle has potential to be a better pickle over this pickle. But this pickle is going to eat up slightly more memory. But the memory is accessed quicker than the memory in this pickle. So that's, I don't know if that even explains it. That's why I'm stuck. So I gotta update it to work in the first mode with RAM, and the second mode with paging. So I can speed test both of these to figure out which is more performant. I don't know if the pictures helped any. I gotta stop stalling. So right now, it's running in this mode. Here, mode 1, I'm inserting a test function, speed test function. I'm gonna get the speed compared to the browser. And now I'm gonna finish updating both these modes to get rid of unsigned in, put in a size T, and then put in 64-bit arithmetic. And then I'll decide, because I'm gonna have to like test which of these methods will be faster, because I have no clue.
Wait. In a result, if completion is a throw.
But my gut says method 2 is gonna be faster. And I want to go with my gut, but I gotta test both. Because it's so complicated, there's so many parts. I gotta think for a second. I gotta get some water. I drink the whole glass of water, and I'm out of water. I need like 20 glasses of water.
Less deteriorate.
Because if I don't drink the water, I forget. And if I drink the water, I drink all of it at once, and I'm like fucking thirsty. I'm in a pickle though. I'm gonna pick between these two pickles later. Okay, so after I don't know if it explains it any better. I had to stall the thing. I'm gonna take a break and be back. When I get back, I'm gonna work on this speed test thing. I'm not gonna talk at all, because I was get distracted. But after the speed test, I'm gonna do two things for both pickles. And I'm gonna stop. Oh, it wasn't even highlighted. Okay, so I'm gonna do these things when I get back, the speed test, whatever, and then I hit this zoom tool. After the speed test, I'm not gonna talk, I'm just gonna get it done.
It performs the.
After that, I'm gonna update both pickle modes. Get rid of this unsigned in. I have new files now because the malloc RAM mode. I didn't do those files yet. But since I support that build mode, I gotta do those files. So I'm gonna do all the files, get these unsigned ins out, signed in, all of them. And then I'll convert everything that's open, those files, 64-bit. I'm not gonna think about testing anything yet. I'm just gonna get all updated. That's what I'm gonna do.
0. Copyright sign. ECMA International.
Because it's like, it's so freaking complicated. And if I pick the wrong decision, it'd be a waste of time to update one or the other when I should have picked the other.
Modules default.
So I gotta pick them both. And drink some water, and then decide after testing them to figure out which is faster. And I don't know. Whenever I figure out which one is faster, I'm not going to tell you. That's for me to know. So, I don't know. Knowledge is power. I'm going to tell you very little. I'll drop hints, but the amount of time invested, I'm not giving you shit. I'll like draw diagrams and stuff, but when I figure out the faster one, the better method, I'm just gonna go with it. And yeah, because if I tell you which is faster, it'll be easier to like copy me, be like, I'm the second guy, person, human that made the JavaScript Engine in C. It'll just copy what I did. This way, if you want to copy me, you're gonna have to go through twice the amount of work, not knowing which one's better. You don't even know how I implemented this stuff. With the like, you're gonna have like a really vague idea. I don't know. Good luck. I got like such a huge head start. So, I'll be back. I'll pick between these later. Let's try to see this. I'll deal with this later. I'm gonna be back. I'll do a stupid speed test. Then I'll convert these. And then I'll pick a pickle. So many choices. Okay, I'll be back.
Element list.
I'm not gonna talk. Just whatever. If I talk, I'm not gonna stop. It's so much easier to like think about what you're gonna do than actually do it. A lot easier. But I need to get something done, so.
The list concatenation of names 1 and names 2. Binding element list. Binding element list. Binding elision element. Let names 1 be bound names of binding element list. Let names 2 be bound names of binding elision element. Return the list concatenation of names 1 and names 2. Binding elision element. Elision not binding element 1. Return bound names of binding element. Binding property. Property name. Binding element 1. Return the bound names of binding element. Single name binding. Binding identifier initializer opt1. Return the bound names of binding identifier. Binding element. Binding pattern initializer opt1. Return the bound names of binding pattern. 2. ECMA International 2024. For declaration, let or const for binding 1. Return the bound names of for binding. Function declaration. function binding identifier, formal parameters, function body, 1. Return the bound names of binding identifier, function declaration, function, formal parameters, function body, 1. Return default, formal parameters, empty, 1. Return a new empty list, formal parameters, formal parameter list, function rest parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of function rest parameter. Return the list concatenation of names 1 and names 2, formal parameter list, formal parameter list, formal parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of formal parameter. Return the list concatenation of names 1 and names 2. Arrow parameters. Capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return the bound names of formals. Generate a declaration, function binding identifier, formal parameters. Generate a body. Return the bound names of binding identifier. Generate a declaration, function, formal parameters. Generate a body. Return default. Async generate a declaration. Async function binding identifier, formal parameters. Async generate a body. Return the bound names of binding identifier. Async generate a declaration. Async function, formal parameters. Async generate a body, 1. Return default. Class declaration. Class binding identifier class tail 1. Return the bound names of binding identifier. Class declaration. Class tail 1. Return default. ECMA International 2024-93. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Return the bound names of binding identifier. Async function declaration. Async function. Formal parameters. Async function body. Return default. Capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. Member expression arguments. Let head be the async arrowhead that is covered by capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. Return the bound names of head. Import declaration. Import clause from clause 1. Return the bound names of import clause. Import declaration. Import module specifier 1. Return a new empty list. Import clause. Imported default binding. Namespace import. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of namespace import. Return the list concatenation of names 1 and names 2. Import clause. Imported default binding. Named imports. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of named imports. Return the list concatenation of names 1 and names 2. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. Let names 1 be the bound names of imports list. Let names 2 be the bound names of import specifier. Return the list concatenation of names 1 and names 2. Import specifier. Module export name as imported binding 1. Return the bound names of imported binding. Export declaration. Export from clause. Export named exports. Return a new empty list. Export declaration. Export variable statement. Return the bound names of variable statement. Export declaration. Export declaration. Return the bound names of declaration 94. ECMA International 2024. Export declaration. Export default hoistable declaration. Let declaration names be the bound names of hoistable declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default class declaration. Let declaration names be the bound names of class declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default assignment expression. 1. Return default, 2.2 static semantics. Declaration part. The syntax-directed operation declaration part takes no arguments and returns a parse node. It is defined piecewise over the following productions: hoistable declaration, function declaration, return function declaration, hoistable declaration, generator declaration, return generator declaration, hoistable declaration, async function declaration, return async function declaration, hoistable declaration, async generator declaration, return async generator declaration, declaration, class declaration, return class declaration, declaration, lexical declaration, return lexical declaration, 2.3 static semantics, is constant declaration. The syntax-directed operation is constant declaration takes no arguments and returns a boolean. It is defined piecewise over the following productions: lexical declaration, let or const binding list. Return is constant declaration of let or const. Let or const, let return false. Let or const, const return true. ECMA International 2024 95. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return false, class declaration, class binding identifier class tail 1. Return false, export declaration, export from clause, export named exports, export default assignment expression, return false, 2.4 static semantics, lexically declared names. The syntax-directed operation lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: block, return a new empty list, statement list item. Let names 1 be lexically declared names of statement list. Let names 2 be lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement, if statement is statement, labeled statement, return lexically declared names of labeled statement. Return a new empty list. Statement list item. Declaration. Return the bound names of declaration. It is not necessary to treat export default assignment expression as a constant declaration. Note, because there is no syntax that permits assignment to the internal bound name used to reference a module's default object. 6. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let names 1 be the lexically declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be lexically declared names of default clause. If the second case clauses is present, let names 3 be the lexically declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3 case clauses, case clauses case clause. Let names 1 be lexically declared names of case clauses. Let names 2 be lexically declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically declared names of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically declared names of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration. Return bound names of function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return top-level lexically declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top-level lexically declared names of statement list. Concise body. Expression body 1. Return a new empty list. ECMA International 2024. 97. A concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top-level lexically declared names of statement list. Note 2. The lexically declared names of a module includes the names of all of its imported bindings. Module item list. Module item list. Module item. Let names 1 be lexically declared names of module item list. Let names 2 be lexically declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Return the bound names of import declaration. Module item. Export declaration. If export declaration is export variable statement, return a new empty list. Return the bound names of export declaration. Module item. Statement list item. Return lexically declared names of statement list item. 2.5 Static semantics. Lexically scoped declarations. The syntax-directed operation lexically scoped declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be lexically scoped declarations of statement list. Let declarations 2 be lexically scoped declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return lexically scoped declarations of labeled statement. Note 1 at the top level of a script. Function declarations are treated like var declarations rather than like lexical declarations. Note 3 at the top level of a module. Function declarations are treated like lexical declarations rather than like var declarations. Return a new empty list. Statement list item. Declaration. Return a list whose sole element is declaration part of declaration 98. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let declarations 1 be the lexically scoped declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be lexically scoped declarations of default clause. If the second case clause is present, let declarations 3 be the lexically scoped declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses case clause. Let declarations 1 be lexically scoped declarations of case clauses. Let declarations 2 be lexically scoped declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically scoped declarations of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration 1. Return function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. ECMA International 2024-99. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let declarations 1 be lexically scoped. Declarations of module item list. Let declarations 2 be lexically scoped. Declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Export declaration. Export from clause. Export named exports. Export variable statement. Return a new empty list. Export declaration. Export declaration. Return a list whose sole element is declaration part of declaration. Export declaration. Export default hoistable declaration. Return a list whose sole element is declaration part of hoistable declaration. Export declaration. Export default class declaration. Return a list whose sole element is class declaration. Export declaration. Export default assignment expression. Return a list whose sole element is this export declaration. 00. ECMA International 2024. 8. 2. 6 static semantics. var declared names. The syntax-directed operation var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, return a new empty list. Block, return a new empty list. Statement list. Statement list item. Let names 1 be var declared names of statement list. Let names 2 be var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration 1. Return a new empty list.
Variable statement, variable deklaration list. 1. Return both names of variable deklaration list.
If statement. If expression statement else statement. Let names 1 be var declared names of the first statement. Let names 2 be var declared names of the second statement. Return the list concatenation of names 1 and nam s2. If statement. If expression statement 1. Return the var declared names of statement. Do while statement. Do statement while. Expression 1. Return the var declared names of statement while statement. While. Expression statement 1. Return the var declared names of statement for statement. 4. Expression not. Expression not. Expression not statement 1. Return the var declared names of statement for statement. 4. var variable declaration list. Expression not. expression or statement. Let names 1 be bound names of variable declaration list. Let names 2 be var declared names of statement. Return the list concatenation of names 1 and names 2. ECMA International 2024 101. For statement. 4. Lexical declaration expression or statement 1. Return the var declared names of statement for in of statement. 4. Left-hand side expression in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement. Return the var declared names of statement for in of statement. 4. var for binding in expression statement. 4. var for binding of assignment expression statement for await. var for binding of assignment expression statement. Let names 1 be the bound names of for binding. Let names 2 be the var declared names of statement. Return the list concatenation of names 1 and names 2. Note this section is extended by an XB 3.5 with statement with expression statement 1. Return the var declared names of statement switch statement switch expression case block 1. Return the var declared names of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let names 1 be the var declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be var declared names of default clause. If the second case clauses is present, let names 3 be the var declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clauses case clause. Let names 1 be var declared names of case clauses. Let names 2 be var declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. 1. 2. If the statement list is present, return the var declared names of statement list. Return a new empty list. 02. ECMA International 2024. Default clause. Default. Statement list opt. If the statement list is present, return the var declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var declared names of label ed item. Labeled item. Function declaration. Return a new empty list. Try statement. Try block catch. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Return the list concatenation of names 1 and names 2. Try statement. Try block finally. Let names 1 be var declared names of block. Let names 2 be var declared names of finally. Return the list concatenation of names 1 and names 2. Try statement. Try block catch finally. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Let names 3 be var declared names of finally. Return the list concatenation of names 1, names 2, and names 3. Catch. Catch parameter, block 1. Return the var declared names of block. Function statement list, empty, 1. Return a new empty list. Function statement list. Statement list. Return top level var declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top level var declared names of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. ECMA International 2024 103. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var declared names of statement list. Module item list. Module item list module item. Let names 1 be var declared names of module item list. Let names 2 be var declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return bound names of export declaration. Return a new empty list. 2.7 static semantics. var scope declarations. The syntax directed operation var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, return a new empty list. Block, return a new empty list. Statement list. Statement list item. Let declarations 1 be var scope, declarations of statement list. Let declarations 2 be var scope, declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Declaration 1. Return a new empty list. Variable declaration list. Variable declaration 1. Return variable declaration. Variable declaration list. Variable declaration list. Variable declaration. 2. Let declarations 1 be var scope, declarations of variable declaration list. Return the list concatenation of declarations 1 and variable declaration. 04. ECMA International 2024. If statement. If. Expression statement else statement. Let declarations 1 be var scope, declarations of the first statement. Let declarations 2 be var scope, declarations of the second statement. Return the list concatenation of declarations 1 and declarations 2. If statement. If. Expression statement. Return the var scope, declarations of statement. Do while statement. Do statement while. Expression. 1. Return the var scope, declarations of statement. While statement. While. Expression statement 1. Return the var scope, declarations of statement. For statement. 4. Expression not. Expression not. Expression not statement 1. Return the var scope, declarations of statement. For statement. 4. Var variable declaration list. Expression not. Expression not statement. Let declarations 1 be var scope, declarations of variable declaration list. Let declarations 2 be var scope, declarations of statement. Return the list concatenation of declarations 1 and declarations 2. For statement. 4. Lexical declaration expression not. Expression not statement 1. Return the var scope, declarations of statement. For in of statement. 4. Left-hand side expression in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. For declaration of assignment expression statement. Return the var scope, declarations of statement. For in of statement. 4. Var for binding in expression statement. 4. Var for binding of assignment expression statement. For await. Var for binding of assignment expression statement. Let declarations 1 be for binding. Let declarations 2 be var scope, declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB. 3.5. With statement. With expression statement. Return the var scope, declarations of statement. Copyright sign. ECMA International 2024 105. Switch statement. Switch. Expression. Case block 1. Return the var scope, declarations of case block. Case.
If you're watching the stream, then stop and then go live your life. Like, you got your own stuff to do, just go. I'm just documenting this to document it. If you're sitting here watching, you could fast forward or whatever later. So stop watching and go live your life. Go away. Okay, anyways, I'm gonna not talk and find an entry point to call a stupid whatever what do they call it?
Expression. Statement list opt.
This crap function. An entry point to call the crap function in a loop. That's how fast it is. After talking about the array stuff, I'm gonna have to
New empty list.
adjust the loop to make sure the indice isn't super big.
Item. Labeled item.
Because it does 1 to the 6 exponential. I don't know. I think it's like 6 zeros after the 1. I know. Okay. Doesn't matter. There's however many iterations. It's a number. It's a big number. I don't want it to make super big allocs or RAM calls, whatever, because I don't have it set up for sparse data types yet. And I'm not going to do that till I go through the standard and add that. So for now I don't have that. So I have to adjust this loop a teeny bit. But it'll still be a speed test or whatever. I'll give it whatever, I don't know.
It's 2.
So I'm going to get to that and I'm going to stop talking. Stop watching. Go live your life. Get out of here.
Catch parameter. Block. Return the var scope declaration.
I have to say like, I don't know. I don't have anything really cringy to say right now. So I can't like make you leave by being cringy. But this is kind of cringy, pretending I'm like talking to someone watching. If you're watching, go away. Live your life.
Expression body 1.
So I'm like gonna shut up and do this thing. Find an entry point. Call a stupid function. I had a to-do list. But it's a good thing I'm doing this. I don't know. I would have had to go through this anyways. It's really hard to make a decision, and every decision takes up so much time to do. So I'm going to do something now. Stop trying to make decisions, because it's an endless loop. I'm going to just call this function. After I adjust it, test the speed, and then get these 2 steps over with. Then this step. Then it's down to a
List. Statement list item. Let names 1 be top level lexically.
it didn't zoom. It ruins my whole. I was trying to like smoothly transition this. Then it's down to pickle business. I can't get to pickle business until this is all done. So I'm gonna do this, then get to pickle business. So I'm gonna stop talking, focus, and yeah.
Capital L E X I C A L L Y. Capital S C O P E D. Capital D E C L A R A. The syntax directed operation. Capital T O P. Capital L E V E L. Capital L E X I C A L L Y. Capital S C O P E D. Capital D E C L A R A. Takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. Let declarations 2 be capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement.
Okay, last thing.
Hoistable declaration.
I really can't focus.
2.10 Static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top level var declared names of statement list. Let names 2 be top level var declared names of statement list item. Return the list
Or not.
declaration. Then a return the bound name.
I don't think Windows is capable of opening Paint unless it opened in the other window.
Level of a function or script. Function declarations are treated like var declarations rather.
It didn't.
Statement list item.
So Paint isn't even, it just disappeared. Oh, here it is.
Level of a function or script.
Yeah, it did open another window.
Labeled statement. Label identifier. Labeled item. Return the top level var declared names of labeled item. Labeled item. Statement. If statement is statement. Labeled statement. Return top level var declared names of statement. Return var declared names of statement.
Was I showing it on the blurry screen the whole time? Probably wasn't even visible. Dang it. Whatever. Between these two modes, whatever.
Nodes. It is defined piecewise over the following productions.
Opening Paint.
Statement list item. Let declarations 1 be top level var scope. Declarations of statement.
I need to stop and actually focus.
Concatenation.
But these two modes.
Statement. If statement is statement. Labeled statement. Return top level var scope.
I could add
stable declaration. Then a let
to the first mode, whatever. A little cache.
Identifier. Labeled item. Return the top.
That's like the second mode.
Labeled item. Statement.
Or if it's a large array, I must set like 10 million to it. You can save it here.
Return. Labeled item. Function deck.
Maybe I said like the key of 2 or something.
Right sign. ECMA International 2.
And I said like the key like 99.
Semantics. The syntax directed operation contains.
I could possibly make a mini cache for this data structure
Ways over the following production.
that's like this one,
Empty statement expression.
but it'll be local to each of the slabs themselves. So each malloc would have its own little cache. And if it's like a flat array that doesn't need this sparse tree, like the whole data tree, I could not use this at all.
Label set.
And I would make it just a normal array, but like a little piece of it used to manage this head chunk, descript or whatever.
Return contains duplicate label.
And then have like 3 modes. Have like the normal mode, have it as an array mode, and then also has, if it's like a really big sparse array, and the performance overhead and amount of memory, if a lot would be wasted, I could check the distance between the keys in the array to store them to a little cache instead.
Var variable declaration list. Expression not. Expression not.
But when stored to a cache,
Expression.
the normal array, the flat array, it's not going to need this cache at all
Label set.
because everything would be literally just accessed by offset in the array.
Statement 4. Var for binding in expression.
That might be the best option. But it might not be, because I updated the entire thing for both modes. This mode uses snail allocation. This one, I updated the whole data structure, so every check or whatever goes through a larger cache. And this one might be more optimal when the hard drive is removed and it's just RAM. So I need to stop thinking about this and focus on getting the entry point and calling the speed test, and then I'll get to this after I convert the files. But I am going to convert all the files I need now, so I can do both of these cases, because I can't pick one or the other yet. I can think ahead on how I tweak them, but there's no point in doing that until like I get to that point. So I need to stop thinking ahead, and I'm gonna just do something. I'm gonna stop thinking, and I'm gonna do something. I'm going to stop thinking. I hate wasting time. I don't think I'm gonna save any time trying to think ahead. And adding this is more work. So I'd have to test it first between the two and then add this. So I'm stopped. I'm done thinking ahead. I'm gonna get the whatever test function running. I like this one though better because it uses like the RAM, like chunks of RAM. It's all like, I like this mode. It's more fancy. So I'm gonna get the test function and deal with this stuff later.
Statement. Try block catch finally. If contains duplicate labels of block with argument label set as true, return true. If contains duplicate labels of catch with argument label set as true, return true. Return contains duplicate labels of finally with argument label set. Catch parameter, block. Return contains duplicate labels of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. Let has duplicates be contains duplicate labels of module item list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argum empty label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If statement, if expression statement else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If statement, if expression statement. Return contains undefined break target of statement with argument label set. Do while statement. Do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. For. Expression not. Expression not. Expression not statement. For. var variable declaration list. Expression not. Expression not statement. For. Lexical declaration expression not. Expression not statement. Return contains undefined break target of statement with argument label set. For in of statement. For. Left-hand side expression in expression statement. For. var for binding in expression statement. For declaration in expression statement. For. Left-hand side expression of assignment expression statement. For. var for binding of assignment expression statement. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this.
I have one thing that throws an invalid operation combination. And I don't know if I had it throwing that as an actual error or debug. So it's like debugging that combination. I don't know, there's like a couple things I gotta like check. I'm gonna wait until later. So I gotta like dig through the whole thing. I'm trying to find where it prints to the screen so we can find like code next to it to find an entry point. Oh, that's why I ran across this error or possible error. I might have just been debugging. But here's I think 831.
Statement list.
Type combinations.
Find break target of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier.
It's not even a power of 2. Oh, there's a lot of operations.
Undefined break target of block.
Must be a lot more. Let me add 4 more types.
Try block finally. Let has undefined. True if contains undefined break target of.
I need to soundtrack. There's like so many things that might have to change and rework.
To block with argument labels, function statement.
So just stop looking for them and then deal with them when they happen. I already have like, I'm gonna find entry point. Whatever.
Module item with argument label set. Module item. Import declaration. Export declaration. Return false. Comma 3.3 static semantics. Capital C. O.
Like every decision sucks. But if there's like a less sucky decision, I want to pick that. But I can't.
O-N-T-I-N.
Can't like. There's no workaround. All decisions are gonna suck.
N-D-E-F-I-N-E-D. Capital C-O-N-T-I-N-U-E. Capital T-A-R-G-E. Takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, star, team and list item, declaration, return false, statement, block statement, return, capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E.
Okay, so
R, G.
the other day, possibly the other day, whatever day it was, yesterday or the day before, I picked where I wanted the entry point at the bottom of one of the functions. I was like, oh shit, this is a mini test mode. It doesn't even call this. It's included, but it's not being called, so it can't call the entry point. So, looking through the logout, I left it in place, whatever. I have discovered this. I have discovered that this zoom tool on Windows, it sucks. But also, that was a rediscovery. I always discover how bad the zoom tool is. But I've also found this. JavaScript stress test, function, chatbot, output, speed test, start, end. So, it means that when I run the full test mode in the malloc mode, this build option is calling and running the exact function that I needed. So I found the entry point. I don't have to keep looking. I'm really happy. This saves me like, I don't know. I'm so tired of this. So now I can convert this crap code here. Like finally fucking convert it, and then it will run where the entry point is that I found the other day. That I had to go through whatever. I don't know. I still have a bunch of stuff to figure out now, but along that whole journey, how this is being called so I can convert it and call it right here. So I need to think some more. I wasn't planning to find it this quick or at all. I didn't think this would be called, but it is. So that's good. So I can convert it, put it here, and then after this, I'll run it, see how fast it is. It's in the malloc mode, that works. And then after this, I will get back to this. Hopefully, I have more files now, because I have more files to check, because I added more files. I added more files, because I added more modes, because I needed more modes to find entry point, and now I have my entry point, which is right freaking here. So now, I need to go to this entry point. I'm gonna run this. Everything's finally coming together. I'm gonna run this crap function here. I gotta convert it, whatever, so I'm gonna do that. Convert it, run it. After it runs, I'll see how much faster it is than Google Chrome. And it will be faster, because it has to be. There's no way it's not. But I will see how much faster. And then, after that, I'm gonna turn it off, whatever, that block. It's probably gonna mess up this. I'm gonna use the globals. They might be in use. So I'll have it like kill the program right here, so I don't mess up what happens after it. Because there's a bunch of stuff that's cold. So, after that, I will know how fast it is, and I'll feel like more confident with finishing this thing. And then all the new files that I added for this sake here, I'm going to just get the rest of these fucking ints and stuff, get the tag, keyword in place. Hopefully I can do that in a couple hours if I just focus and go through and get them all done. When they're all done, all that's left is this. That's all. I just have to convert everything to 64-bit addressing. And then I have 2 days left. But that's what I have planned. I plan to do this in 14 days. And I got 2 days left. So maybe this can be done in 2 days. If it can, then I'm on schedule. And then it's on to, oh fuck. I'm not gonna look ahead. I'm just gonna focus on this stuff here. Get done now. And later on I'm gonna have to deal with pickle business. I'm gonna have to figure out what the fuck is wrong with Sublime 4. And then I'm gonna have to do OpenGL. So, for now, I'm going to only focus on this. And right now, this, I'm going to put the crap function right here, so that's done. I'm gonna take a break. I gotta go think. I wasn't expecting to actually find it this quick, or for this to pop up at all, but it did, which is really good, because this is where I wanted to call it. So I actually got exactly what I want for once, and way too long. So I have to go think, because I was expecting to like keep digging through code, and as I think I was doing it, but now that I found it, I'm gonna be back.
Capital CONAINS, capital UNDEFINED, capital CONTINUE, capital TARGET, of statement with arguments iteration second. Switch statement, switch, expression, case block, return, capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case blow, CK with arguments iteration second. Case block, return false, case block, case clause assopt, default clause case clause assopt. If the first case clauses is present, then A if capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of the first case clauses with arguments iteration second is true, return true, if capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of default clause with arguments iteration second is true, return true if the second case clauses is not present, return false, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of the second case clauses with arguments iteration second. Case clauses, case clauses, case clause. Let as undefined labels be capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case clauses with arguments iteration second. If has undefined labels is true, return true, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case clause with arguments iteration second. Case clause, case expression, statement list opt. If the statement list is present, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of statement list with arguments iteration second. Return false, default clause, default, statement list opt. If the statement list is present, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of statement list with arguments iteration second. Return false, labeled statement, label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of labeled item with arguments iteration set to new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of block with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of catch with arguments iteration set and ECMA International 2024 117. Try statement. Try block finally. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of block with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E finally with arguments iteration set and try statement. Try block catch finally if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of block with arguments iteration set and is true, return true. If capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of catch with arguments iteration set and is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E finally with arguments iteration set and catch parameter block return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a block with arguments iteration set and function statement list empty 1 return false class static block statement list empty 1 return false module item list module item let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a module item list with arguments iteration set and if has undefined labels is true return true return cont aims undefined continue target of module item with arguments iteration set and module item import declaration export declaration return false point 4 function name inference comma 4.1 static semantics has name the syntax directed operation has name takes no arguments and returns a boolean. It is defined piecewise over the following productions primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N if as function definition of expa is false return false return his name of expa function expression function formal parameters function body generator expression function formal parameters generator body async generator expression async function formal parameters async generator body async function expression async function formal parameters async function body 18 ECMA International 2024 arrow equals concise body async arrow function async arrow binding identifier equals async concise body capital C O V
Test. Okay, so now I'm gonna like actually focus. Possibly. I'm gonna stop talking. I'm gonna adjust this crap function. I have a copy somewhere before I mess with it and change it. I'm gonna get the original and then I'm gonna tweak it again. I gotta get rid of the push because I don't have a push in my engine until I meet the once I meet the standard I will. Until then
function binding identifier
I'm gonna mask where it's multiplying by 177. I'll mask the in count or the result or something to some like how much space is this? Oh, it's right now it's 32-bit. I have to make it smaller so it won't take up more than 4 gigs. The array that it makes. So I don't know. Because I don't have sparse arrays yet. So I'm going to adjust this crap function and speed test it. So I have the entry point. So I'm going to do that.
N capital A
I don't know why I have anxiety. It's going to be faster because all the other tests are faster, so I don't know how this wouldn't be faster. Other than the fact that it's unoptimal, and I could see it affecting the speed because of the fact that it's extremely unoptimal. So I'm going to just do this, get over with. Anxiety.
Optional expression. ECMA International 2020.
If it does end up being faster, that'd be horrible. I'd be like, fuck. Because then I'd have to like optimize it even more to account for unoptimal code that does weird things, like make an object every single loop and only keep like every like 5th or 6th object. Because I have it set up right now to like make an allocation, it uses the memory. There's no like just funky stuff. But people write funky code. And people make arrays with holes in them. They don't use a whole array. I set it up for like a C program, whatever, where it's everything is I don't just waste memory. Everything's like really tight in memory. So I'm gonna speed test this and see how it goes.
Expression equality. Expression equals.
Listen to some really loud music, and hopefully I can focus and get this over with so I can get to the rest of the stuff.
Expression bitwise or expression bitwise or expression logical and expression logical and
And I'm not tired yet, which is good. So I want to get this like done with. So like whenever I'm like tired, whatever, all I have left is finding replacing types, and then I might have to like tag areas where it's 64-bit arithmetic is needed, or I'll update it, but it might be better to tag areas first and come back and update it later after I get like a look at all the code around it that's related before I start like just updating things to 64-bit to get like a better overview, and then it's into pickle business. And that's to be a whole other thing that I gotta figure out. I just want to get to standards. That's the whole point. And Windows made like a sound. The program's still running, the software, so I don't think the stream's dead, but I don't know why Windows went doo-doo-doo-doo. So I don't know. I'm gonna try to focus.
function definition that does not bind a name. It performs the following steps when called. If as function definition of expa is false, return false. Let has name be has name of expa. If has name is true, return false. Return true. 4.4 static semantics is identifier ref. The syntax directed operation is identifier ref takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, identifier reference, return true. ECMA International 2024 121.
And I'm gonna listen to one song on loop over and over because if I listen to like a playlist or like a random shuffle playlist, if there's a bad song in there or something I want to listen to or something that I already listened to over and over, it's going to throw me off. I'm not going to be able to focus. So I'm going to just loop the song over and over. So if it looks like I'm like listening to the same song over and over, it's because I am. That's why it's going to loop. So I don't know. Judge me, whatever. I don't care. I don't know. That's what I'm going to do. So I'm going to try to focus now and see how that goes.
Call expression, optional expression, return false, comma for.
And I don't know. Slaughter to prevail. That's a good hardcore rock band.
A normal completion containing a
Or metal, I don't know. It's heavy.
over the following productions. Primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return. Named evaluation of expa with argument name, parenthesized expression. Expression, assert, is anonymous function definition. Expression is true. Return. Named evaluation of expression with argument name, function expression. Function, formal parameters. Function body. Return, capital I N S T A N T I A T E, capital O R D I N A R Y, capital F U N C T I O N, capital E X P. A function expression with argument name. Generator expression, function, formal parameters. Generator body. Return, capital I N S T A N T I A T E, capital G E N E R A T O R, capital F U N C T I O N, capital E X. Of generator expression with argument name. Async generator expression. Async function, formal parameters. Async generator body. Return, capital I N S T A N T I A T E, capital A S Y N C, capital G E N E R A T O R, capital F U N C T. Of async generator expression with argument name. 22. Copyright sign, ECMA International 2024. Async function expression. Async function, formal parameters. Async function body. 1. Return, capital I N S T A N T I A T E, capital A S Y N C, capital F U N C T I O N, capital E X P R E S. Of async function expression with argument name. Arrow function. arrow parameters equals concise body. Return capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S arrow function with argument name async arrow function async arrow binding identifier equals async concise body capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body. Return capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E of async arrow function with argument name class expression class tail let value be class definition evaluation of class tail with arguments undefined and name set value to the source text match by class expression return value 0.5 contains 5.1 static semantics contains the syntax directed operation contains takes argument symbol a grammar symbol and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains for each child node child of this parse node. Do I if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier opt. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. ECMA International 2024 123. Async function expression. Async function binding identifier opt. Formal parameters. Async function body. Return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail. Class heritage art. Class body. If symbol is class body, return true. If symbol is class heritage, then if class heritage is present, return true. Otherwise return false. 3. If class heritage is present, then if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block. Static. Class static block body. 1. Return false. Arrow function. Arrow parameters equals concise body. If symbol is not one of new target, super property, super call, super, or this, return false. If arrow parameters contain symbol is true, return true. Return concise body contains symbol. Arrow parameters. Capital C O V E R capital P A R E N T H E S I Z E D capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return formals contain symbol, async arrow function, async arrow binding identifier equals, async concise body. If symbol is not one of new target, super property, super call, super, or this, return false. Return async concise body contains symbol, async arrow function, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body. If symbol is not one of new target, super property, super call, super, or this, return false. Let head be the async arrow head that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. If head contains symbol is true, return true. Return async concise body contains symbol. 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class S bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true, return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super, return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true, return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true, return true. Return false. 5.2 static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions. Class element name, private identifier, property name, literal property name, return false, property name, computed property name. Return the result of computed property name contains symbol. Method definition, class element name, unique formal parameters. Function body, get class element name. Function body, set class element name, property set parameter list. Function body, return the result of computed property contains of class element name with argument symbol. Generator method, class element name, unique formal parameters. Generator body, return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. Async generator method, async class element name, unique formal parameters. Async generator body, return the result of computed property contains of class element name with argument symbol. Class element list, class element list class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. Class element. Class static block 1. Return false. Class element 1. Return false. Async method. Async class element name. Unique formal parameters. Async function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition. Class element name initializer. Return the result of computed property contains of class element name with argument symbol. Point 6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax directed opera. T on instantiate function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, a function declaration with argument CNV and private env. Generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, of generator declaration with argument CNV and private env. Async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, of async generator declaration with argument CNV and private env. 26. ECMA International 2024. Async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return instantiate async function object of async function declaration with argument CNV and private env. 6. To runtime semantics, binding initialization. The syntax-directed operation binding initialization takes arguments value, an ECMAScript language value, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding identifier, identifier, let name be string value of identifier, return, initialize bound name, name, value, environment, binding identifier, yield, return, initialize bound name, yield, value, environment, binding identifier, await, return, initialize bound name, await, value, environment, binding pattern, object binding pattern, perform, require object coercible, value, return, binding initialization of object binding pattern with arguments value and environment, binding pattern, array binding pattern, let iterator record be, get iterator, value, sync, let result be completion, iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return, iterator close, iterator record, result, return result, object binding pattern, 1. Return unused, object binding pattern, binding property list, perform, property binding initialization of binding property list with arguments value and environment, return unused, note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is HOI, stead and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern. Binding rest property. Let excluded names be a new empty list. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding rest property. Let excluded names be. Property binding initialization of binding property list with arguments value and environment. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. 6. 2. 1. Initialize bound name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMAScript language value, and environment an environment record or undefined, and returns either a normal completion containing a new store and abrupt completion. It performs the following steps when called. If environment is not undefined, then a perform environment initialize binding name, value be return unused, else a let LHS be. Resolve binding name be return, put value LHS value, 6.3 runtime semantics, iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Array binding pattern. Elision not binding rest element. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Elision not binding rest element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. If elision is present, then a perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, a collision with argument iterator record. Return. Iterator binding. Initialization of binding REST element with arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. Perform. Iterator binding. Initialization of binding element list with arguments iterator record and environment. Return. Iterator binding. Initialization of binding elision element with arguments iterator record and environment. Binding elision element. Elision binding element. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, a collision with argument iterator record. Return. Iterator binding. Initialization of binding element with arguments iterator record and environment. Single name binding. Binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be resolve binding. Binding id environment. Let v be undefined. If iterator record is false, then a let next be iterator step value. Iterator record b. If next is not done, then I set v to next. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v to named evaluation of initializer with argument binding id b. Else I let default value be evaluation of initializer to set v to get value default value. If environment is undefined, return put value LHS v. Return. Initialize reference binding LHS v. Binding element. Binding pattern initializer opt. Let v be undefined. If iterator record is false, then a let next be iterator step value. Iterator record b. If next is not done, then I set v to next. If initializer is present and v is undefined, then a let default value be evaluation of initializer b. Set v to get value default value. Return. Binding. Initialization of binding pattern with arguments v and environment. Binding REST element. Binding identifier. Let LHS be resolve binding. String value of binding identifier. Environment. Let a be array create 0. Let 0 repeat. A let next be done b. If iterator record is false, then I set next to iterator step value. Iterator record c. If next is done, then ECMA International 2024 129. If environment is undefined, return put value LHS a to return. Initialize reference binding LHS a. Deperform. Create data property or throw a to string n. Next set n to n plus 1. Binding REST element. Binding pattern. Let a be array create 0. Let 0 repeat. A let next be done b. If iterator record is false, then I set next to iterator step value. Iterator record c. If next is done, then I return binding. Initialization of binding pattern with arguments a and environment. Deperform. Create data property or throw a to string n. Next set n to n plus 1. Formal parameters. Empty 1. Return unused. Formal parameters. Formal parameter list. Function REST parameter. Perform. Iterator binding. Initialization of formal parameter list with arguments site, rater record and environment. Return. Iterator binding. Initialization of function REST parameter with arguments iterator record and environment. Formal parameter list. Formal parameter list. Formal parameter. Perform. Iterator binding. Initialization of formal parameter list with arguments iterator record and environment. Return. Iterator binding initialization of formal parameter with arguments iterator record and environment. Arrow parameters. Binding identifier. Let v be undefined. Assert. Iterator record is false. Let next be. Iterator step value. Iterator record. If next is not done, then assert v to next. Return. Binding initialization of binding identifier with arguments v and environment. Arrow parameters. Capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let formals be the array formal parameters that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return. Iterator binding initialization of formals with arguments iterator record and environment. Async arrow binding identifier. Binding identifier. Let v be undefined. Assert. Iterator record is false. Let next be. Iterator step value. Iterator record. If next is not done, then assert v to next. Return. Binding initialization of binding identifier with arguments v and environment. 30. ECMA International 2024. 8. 6. 4. Static semantics. Assignment target type. The syntax-directed operation assignment target type takes no arguments and returns simple or invalid. It is defined piecewise over the following productions. Identifier reference. Identifier. If this identifier reference is contained in strict mode code and string value of identifier is either eval or arguments, return invalid. Return simple. Identifier reference. Yield. Await. Call expression. Call expression. Expression. Call expression. Identifier name. Call expression. Private identifier member expression. Member expression. Expression. Member expression. Identifier name super property. Member expression. Private identifier. Return simple. Primary expression. Capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return assignment target type of expa primary expression. This literal array literal object literal function expression class expression generator expression async function expression async generator expression regular expression literal template literal call expression capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. Supercall, import call, call expression arguments call expression template literal, new expression member expression template literal new member expression arguments, ECMA International 2024 131, new target, import meta, left hand side expression, optional expression, update expression, left hand side expression plus, left hand side expression, plus unary expression, unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative operator, exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instancy of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression equals relational 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 expression, bitwise and expression and equality expression, bitwise or expression bitwise and expression, bitwise or expression, logical and expression, and bitwise or expression. 32. ECMA International 2024. Logical or expression, logical and expression, coalesce expression head. Bitwise or expression, conditional expression, short circuit expression, assignment expression, yield expression, arrow function, async arrow function. Left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, assignment expression, return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition. Identifier reference. Return string value of identifier reference. Property definition. Assignment expression. Return empty. Property definition. Property name. Assignment expression. Return prop name of property name. Literal property name. Identifier name, return string value of identifier name. Literal property name, string literal, return the SV of string literal. Literal property name, numeric literal, let NBR be the numeric value of numeric literal, return. To string, NBR, computed property name, assignment expression, 1. Return empty, ECMA International 2024 133. Method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return prop name of class element name, generator method, class element name, unique formal parameters, generator body, return prop name of class element name, async generator method, async class element name, unique formal parameters, async generator body, return prop name of class element name, class element, class static block 1, return empty, class element, 1, return empty, async method, async class element name, unique formal parameters, async function body, 1, return prop name of class element name, field definition, class element name initializer opt1. Return prop name of class element name, private identifier 1. Return empty, executable code and execution contexts 9.1 environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of ECMAScript code. Usually an environment record is associated with some specific syntactic structure of ECMAScript code such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, A new environment record is created to record the identifier bindings that are created by that code. Every environment record has an field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a function declaration contains two nested function declarations, then the environment records of each of the nested functions will have as their outer environment record the environment record of the current evaluation of the surrounding function. Environment records are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 34. Copyright sign. ECMA International 2024. 9. 1. 1. The environment record type hierarchy. Environment records can be thought of as existing in a simple, object-oriented hierarchy where environment record is an abstract class with three concrete subclasses: declarative environment record, object environment record, and global environment record. Function environment records and module environment records are subclasses of declarative environment record. Environment record. Abstract. A declarative environment record is used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier binding S with ECMAScript language values. A function environment record corresponds to the invocation of an ECMAScript function object and contains bindings for the top-level declarations within that function. It may establish and use this binding. It also captures the state necessary to support supermethod invocations. A module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. It is a global environment record. An object environment record is used to define the effect of ECMAScript elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It is null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. The environment record abstract class includes the abstract specification methods defined in Table 16. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Table 16. Abstract methods of environment records. Method purpose has binding n. Determine if an environment record has a binding for the string value n. Return true if it does and false if it does not. Create mutable binding n. D. Create a new but uninitialized mutable binding in an environment record. The string value n is the text of the bound name. If the Boolean argument d is true, the binding may be subsequently deleted. Create a mutable binding n. S. Create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. If s is true, then attempts to set it after it has been initialized will always throw an exception, regardless of the strict mode setting of operations that reference that binding. Initialize binding n. V. Set the value of an already existing but uninitialized binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. Set mutable binding n. V. S. Set the value of an already existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. Copyright sign. ECMA International 2024. 35. Table 16. Abstract methods of environment records. Continued. Method purpose. Get binding value n. S returns the value of an already existing binding from an environment record. The string value n is the text of the bound name. S is used to identify references originating in strict mode code or that otherwise require strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception.
Okay, so this will take whatever the index is,
Binding for N exists, remove
shift top 4 bits of the loop count or whatever, bottom. So when it hits the higher numbers, the bottom bits will be whatever this number is. And I shift the count up 4 bits left and keep only $12 bits. So I mask it. It's like 4,000 something, I think.
The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms: 1, 1, 1, 1.
So the array that makes whatever possibly be 4,000 bytes.
It performs the
And these many iterations.
binding N D. The create mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and e, a boolean, and returns a normal completion containing unused. It creates a new mutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if d is true.
It's I don't know, it's fine.
Is uninitialized.
It's not that big of a space, whatever.
May be deleted by a subsequent delete binding.
I think one of these will go a little bit above. So I don't know.
N S. The create a mutable binding
This will kind of possibly use an okay indice for this many iterations, because I don't have a sparse array.
A binding must not already exist in this
This standard, not fair, and it's not. What the heck? Telling me the standard. I don't have the ability to have really large numbers saved to the array.
1, 1, 1.
So this will like stay within range. I don't know, I'll check the number. I think it's good doing this. I'm XORing it with a timestamp. My timestamp's made from current time, redshift 16, XOR the current time, redshift 8, XOR itself, and 0xFF. It's 256 or 255. 0 to 255. So that way,
return unused, 1, 1, 1. 5 set mutable binding N V.
I don't know what the timestamp looks like in JavaScript. I don't remember, I gotta check. If the bottom bits of the time.
Value of the current binding of the
Cosmic bits.
A binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is...
If the bottom bits of the clock
following steps when called. If
Where the time is.
for n, then if s is true, throw a reference error exception. B perform envrec create mutable binding.
Having be all zeros. And I do reach of 16. I cut the number in half.
Set s to true if the binding for n and envrec has not yet been initialized. Then a throw a reference error exception. Else if the binding for n and en.
And I XOR it. So this XOR this.
This is an attempt to change the value of an immutable binding. B if s is true, throw a type error exception. Return unused. Note an example of ECMAScript code.
I need to just run this now.
Function f eval var x equals delete x 0 ECMA International 2024 137 9
Gives this.
6 get binding value n s. The get binding value concrete method of a declarative environment record the envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert envrec has a binding for n. If the binding for n and envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec.
Actually, I'm XORing it with this rigid 8.
Declarative environment record the envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete binding.
And I'm keeping the bottom XOR with itself.
Called assert envrec has a binding for n. If the binding for n and envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1 1 1 8 has this binding. That has this binding concrete method of a declarative environment record the envrec takes no arguments and return.
I'm keeping the bottom 8 bits.
Called return false, 1 1 1 9 has super binding. That has super binding concrete method of a declarative environment record the envrec takes no arguments and returns false. It performs the 1 1 1 0 with base object. The with base object concrete method of a declarative environment record the envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1 1 2 object environment record.
I should probably pick a bigger number.
An object.
Like 12. Or, no. 10.
A name are not included in the set of bound identifiers. Both owned and inherited properties are included in the set regardless of the setting of their attribute.
So it's not like a long byte alignment or whatever.
Environment record norm.
So that way it'll do this. So this XOR this. XOR the original number is 1
8 copyrights
1 0 1 0 1 6 3.
Identifiers bound by an object environment record may potentially change as a side effect of any operation.
And I use this 8 bits. I don't know, I'm doing that in case like the time is like this, and the time is like this. So if it's either all ones, or all zeros and 1/2, whatever, and then in the middle, because I kind of shift, get like something in the middle.
Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records.
So if the time's biased one way or the other, possibly, this might make it more random, or ensure that it's not all 0 or all 1. I probably need a conditional to check that, whatever. It doesn't matter. I'll just check whatever at the end. If I need this, whatever, like a randomized time-ish.
Add at unstoppables. If
To XOR to this indices that I'm clamping here. I guess that's a second ago before this.
to create mutant.
Because the index will it'll get too big. I want to keep it smaller, to keep the array smaller. So doing this stuff to it here will make it smaller. And then XOR that with a timestamp to randomize it so that the compiler won't have the ability to optimize and break up the loop. And it could like ignore the whole loop. It's being set to pixel magma, so it's going to keep this whole object, every indice module 20,000 is 0 remainder,
Record is created with
or not remainder, how many times it fits, whatever. Or it doesn't fit. So X will have the timestamp
returned. ECMA
because the compiler, unless the compiler is smart, it compiles once and then they use their JavaScript optimization at runtime
concrete method of an object environment
to go, oh wait, let's recompile it a second time. They're getting the time and they're not modifying it past this point. So let's get the time, we'll get this timestamp here, and then we'll know beforehand what the result of each loop iteration is, and then they would be able to compute, to break up the loop into a pattern match the reduced iterations. I wanted to like do all the iterations. So assuming that doesn't happen, which you could, I could see doing that. At least not in C, but maybe in JavaScript. So if that prevents that, it may or may not. I think this will work. That's a good test for the two. And then, I don't know. I'm gonna try to run this in Chrome really quick. And I can convert this straight up. I'm gonna get some water to, it's like an hour-ish, I think. I don't know, it's taking too long. I'll convert this here. I was gonna convert the other one, but this one's like done now. So I'll convert this, run in my JavaScript engine, compare, see which one's faster. And then when I add hash map support,
completion containing a
not compare, and this mouse now, and I meet this standard here, I'll have hash map support.
has property binding
And I'll be able to support, I won't have to do this, whatever, to make the number smaller. I'll just use the indice as it is. Because I'll support this stuff. Like I explained earlier, I have a data tree to hold the map, to map an integer, an indice, whatever, of the array or an object to like a higher location, whatever memory, without having to have an actual allocation that's that size. So mine supports that when it meets the standard. Then I won't need to make this number smaller, or like keep it within a reasonable range. So until then I gotta do that with this number. And then when I can't do this, I'm just like whatever, after I meet the standard, this standard, then I'll run this again, and I'll change to not clean up this number, and it should still be faster. And at that point, this will be like a complete JavaScript engine. Or I'm assuming that it will be faster, because if it's faster like this, as an array, as long as my hash map to map the index is faster than what the browser uses, whatever is currently implemented that other people use. As long as it's faster when I meet the standard, however implemented, because I could go this way, and I had another way where I might have to add another cache to this cache over here, number 1. It's not really, can't see the mouse. So whatever I pick, if it's faster than the JavaScript implementation, it runs like this, and then I pick a way that's faster for hashing to a sparse object, whatever. And this should also be faster, assuming so. Because right now I'm assuming that my engine will be faster right now because other tests it was faster. This is all assumption, but it is based off the fact that whatever, I don't know. And I'm sure it'd be possible for JavaScript, whatever the current browser, to be faster at some things, but not other things. So I don't know. Just how like JavaScript is technically sometimes faster than C, but then that depends on how you write the C code, not on the language. So in the end, overall, I think my JavaScript engine will be faster. I need to drink some water. So I'm going to run this first in the browser, and then I'll convert it. And then run my JavaScript engine, and then I'm going to be done with this. Time keeps ticking. It took too long doing this. But I think it's like fair enough. I don't know. I don't want to make a test that doesn't work or isn't helpful because that's a waste of time. So I don't know. I think this will be okay. I just have to check it. So after this, I'm going to do these. Hopefully I can get all these done tonight. I have 2 days left on my countdown. If I get these done the next 2 days, then I'm down to pickle business. I'm gonna have to figure out which one's faster between these two. Probably gonna have to add a mode to test number 1. The mouse is even visible. Is the mouse visible? I don't see the mouse. Why is there no mouse? Now you can see it. It's like this mouse would never. This mouse over here. I don't know. I gotta mess with the settings. So like, I don't know what it's saying. Then I'm done pickle business. That's the whole point. I have to turn the mouse down, there's no point.
One, 1, 3, 5 Get Superbase. The Get Superbase concrete method of a function environment records
Oh, that's all.
either a normal completion containing either an object.
No. The mouse is not. So, I don't know. I'm gonna run this in browser. I'm gonna get some water, I'll be back. Then I'll convert it. I'll run it. Then it's this stuff today. Hopefully I can do all this today because I have more files to do now. And then this tomorrow. And the next day. If I can get this done in 2 days here, then it's pickle business the next day. Hopefully I can get down to pickle business. I need some water, man. I can even talk.
9. The 8th of February 2011. That occur within a script, a global environment.
So I'm gonna try to run this now.
It is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records. Get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record may...
I'll log the timestamp to make sure it's not like 0 or whatever. That it was like a random number. Or somewhat, not random. Whatever the time was. Like, just a value that's not known until it runs, assuming the compiler doesn't do or the JavaScript compiler, assuming it doesn't do a second runtime evaluation for constant values, which I highly doubt, but anything's possible.
The value returned by this in global scope. Hosts may provide any EC.
And if they did, that'd be a pretty clever trick to do. I don't know how useful it would be. Because I'd have to recompile each time anyways. I'm just gonna focus, guys.
The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration. Function declaration. Generator declaration. Async function declaration. Or async generator declaration has lexical declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N. Determines if a corresponding create global var binding call would succeed if called for the same argument. N. Can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument N. Create global var binding. N. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N. V. D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N. The has binding concrete method of a global environment record envrec takes argument n, a string, and
So it took
determines if the argument identifier is one of the identifiers bound by the record. It performs
1,558 milliseconds. And timestamp was 22. I'm gonna run a couple more times.
mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a
And timestamp is 21.
binding for the name, and that is uninitialized. The binding is created in the associated 44 copyright sign ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record.
Something. Didn't copy.
Is true. Throw a type.
Why is it not copying?
D, 1, 1, 4, 3 create a mutable.
Oh my god, this is a piece of shit. Just fucking copy.
Takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name, and that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCL-rec be envrec if DCL.
So I guess the bottom of the number must be like a bunch of zeros. It's a waste. Unless maybe more accurate computer will round differently. Or this number is smaller than they say it is, and they bloat it up and add a bunch of zeros to it. It's really like, I don't know, and I don't care. So.
If the binding exists, it must be in the object environment record. Let objrec be envrec return. Objrec initialize binding n v, 1, 1, 4, 5 set mutable binding n v s.
I'm gonna
Concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then error.
Run this on the Ryzen 5. Stuff has this.
Let objrec be envrec. Return objrec set mutable binding n v s, 1 1 4 6 get binding value n s. The get binding value concrete method of a global environment record envrec takes up
Once I get it.
a boolean and returns
Copy.
a script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, then error return dclrec get binding value n s. ECMA International 2024 145. 3. Let objrec be envrec. Return objrec get binding value n s, 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps.
Okay, copied it to, what is this?
Binding n is true, then a return dclrec delete binding n. Let objrec be envrec. Let global object be objrec has own property global object n. If existing prop is true, then a let status be objrec delete binding n b. If status is true and envrec contains n, then I remove n from envrec. Return status return true, 1 1 4 8 has this binding. That has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1 1 4 9 has super binding. That has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined.
Indie Ryzen 5. Oh, it's kind of old.
1 1
But it's newer than 15 years old.
normal completion contains
Nice. Whatever.
binding. Note: global environment records do not provide a super binding. 9 1 1 4 1 2 has var declaration n. The has var declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a
Open a new notepad.
var declared names be envrec. If var declared names contains n, return true, return false, 1 1 4 1 3 has lexical declaration n. That has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let dclrec be envrec. Return
There is a notepad. Gonna crash the computer. Are you kidding me?
has
What? Fuck.
The has restricted global property concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument
Testing. Is it working? Fuck's sake. God.
called let ob
Notepad. This piece of shit. Freaking crash computer on Notepad. God damn it. I think the stream's still running. Oh, now it's not even opening. It's freaking stupid.
record envrec takes argument n, a string, and returns either a normal complete
Like I can run the web browser and stream, but I open Notepad when it's streaming. It's like, whoa, can't open Notepad. Too much to compute. Freaking crash.
steps when called let objrec be envrec, let global object.
Okay, so this computer we're looking at this time,
global object.
this is definitely a lot faster.
Return true. Return is extensible. Global object. Note properties may exist upon a global object that were directly created rather than being declared using a var function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function.
I'm not printing, dang it. It might not even be running the loop.
Either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global.
Okay, let's see if it's even running the loop.
Steps when called let objrec be envrec, let global object be objrec, let existing prop be global object. N if existing prop is undefined. Return is global object if existing prop is true. Return true if is data descriptor. Existing prop is true and existing prop has attribute values. True enumerable. True return true. Return false, 1 1 4 1 7 create global var binding. N D the create global var binding concrete method of a global environment record envrec takes arguments n, a string, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called let objrec be envrec, let global object be objrec, let has property be.
I can't read it. Notepad.
B is extensible. Global object. If his property is false and extensible is true, then a perform. Objrec create mutable binding. N D be perform. Objrec initialize binding. N undefined. If envrec does not contain n, then a append n to envrec 7. Return unused, 1 1 4 1 8 create global function binding. N V D the create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called let objrec be envrec, let global object be objrec, let existing prop be global object. N if existing prop is undefined or existing prop is true, then a let desc be the property descriptor. V true, true. D else a let desc be the property descriptor. V perform. Define property or throw global object. N desk perform. Set global object. n, v, false. If envrec does not contain n, then a append n to envrec. Return unused. 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object as a proxy will produce the same sequence of proxy trap calls. 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1. 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2 true if the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9. 5. To delete binding, n. The delete binding, g concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n. M. N2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called. Return undefined, 1, 5, create import binding, n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in M's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called. Assert. envrec does not already have a binding for n. Assert. When m is instantiated, It will have a direct binding for N2. Create an immutable indirect binding in env-rec for N that references M and N2 as its target binding and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1. Get identifier reference. env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then I return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding. Name. If exists is true, then I return the reference record. env, name, strict, empty. Else. 150. ECMA International 2024. Note, module environment records always provide this binding. AB. Let outer bn v return. Get identifier reference. Outer. Name. Strict. 9. 1. 2. To new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O. W. E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment. F. New target. The abstract operation new function environment takes arguments F, an ECMAScript function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj-rec the new object environment, G, false, null. Let DCL-rec the new declarative environment, null. Let env be a new global environment record. Set env to obj-rec. Set env to this value. Set env to DCL-rec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024 151. 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined by and Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1. Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9, 2, 1. 1. New private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name pn of names, do if pn is identifier. Then I return pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. Point 3 realms. Before it is evaluated, all ECMAScript code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array, F, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2. As mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9 3 2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes argument realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, b set global obj to ordinary object create intrinsics assert global obj is an object. If this value is undefined, set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec. For each property of the global object specified in clause 19, do a let name be the string value of the property name, b let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desk return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that.
Okay, now I'll run. I'll save
contains whatever implementation specific state is necessary to track the execution progress.
every time that it's whatever.
Execution contexts, component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at
Okay, now it's here it holds a stash, whatever they called it. Whatever check I called it. I need some water. Now it's assigned however many times. And then at the bottom here, it says the first one is 0th to these values of the object. At least I think that's what it said. It has normally in the loop above. So the zeroth will hold something held. And then I have a loop here. I don't have if else yet. I have to find that. I don't want to waste time looking for that. I just want to test it. So I'll make sure there's at least a zeroth thing in the array. Doing this. Whenever I'll loop through the length of them, and I'll XOR and add the result each time.
Context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution context.
Oh, that's good enough. So, at the end of this checksum, it's not a real checksum at this point. Well, I can't compare it because it's not going to have the same result every time. It doesn't matter, I just want the time, assuming that it works in both my engine and this engine, and both that are working, and they can output, loop through after however many were appended to make sure that it actually runs the loop, because at first it's logging it without logging anything tied to the loop, so it means that it could have recognized it, compiled and gone, oh, it doesn't run the loop, and then remove it. But now I force it to loop after the loop above through and access all four properties of each, however many, adds them up, or in the next XORs or whatever. And then it logs it here, and it also logs the length of however many things that were appended or pushed through this array. So try this now.
Is not present or env is undefined. Then, A set env to the running execution context's lexical environment. Assert. env is an environment record. If the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. env.
So why does warp not exist? Didn't I even enter this thing once?
Execution context's lexical environment 2. Repeat. Component purpose. Generator. The generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolved binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Return envrec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Assert envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation WH, and no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Abstract operations which schedule jobs. Such operations accept a job abstract closure and
It says entered 1,000, 10,000. I can't read it. It's too tiny.
realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note: one host environments are not required to treat jobs uniformly. Treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module if script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler,
If EAX is not in undefined reobject, alert this message.
meaning callback, a function object, the function to invoke when the job is invoked. Host defined. Anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps.
It's in range, so
Callback record, callback, empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 hosts call job callback, v, arguments list.
What the fuck?
Back, a job callback arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform.
Is it working now?
Return the result of call job callback v argument. Of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback v arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job realm. The host defined abstract operation host enqueue generic job takes argument.
I was like throwing an error earlier.
Realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without...
What? What the fuck? It was throwing an error. It said it was undefined. And now it doesn't.
5 host enqueue promise job realm.
In here, it clearly wasn't working.
Enqueue promise job takes
This is how scope.
or null and return.
So I moved it out like this. And when I ran it,
The abstract
and it said it's undefined.
with equal priority to promise.
Now it's not throwing undefined. Right or no? I'm so freaking what the fuck.
Each time job is invoked, the implementation must perform implementation defined steps such that
I don't.
let script or module be get active script or module at the time host enqueue promise job is invoked.
I literally spent all the time typing this to figure out why it was alert undefined. Now it's not. So okay.
Same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means...
Oh, this is one. No, it's fine like this. It can't be non-zero. Different decrements. It can be 0 and it's -2, -1.
is not undefined. If the handler is undefined, realm is null. For
I don't know why it was undefined.
is called on a revoked proxy. Realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example error objects, will be created. The WHATWGHTML specification
That's weird.
html.spec.whatwg.org/ for example, uses
You must optimize it.
://html.spec.whatw
Man, it's cheating.
job, timeout job, realm, milliseconds, the host-defined abstract.
We merged the two loops because it recognized that both loop the same number of iterations. It should take twice as long.
Requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global. This value 0. Let global obj be. Set default global bindings. Realm 1. Create any host-defined global object properties on global ob.
So I keep getting it.
A running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most.
Now it's possibly oops less. But I'm not sure.
1 byte values are lock-free. False otherwise is lock-free too.
I have no idea. The timings were so freaking all over the place.
Boolean, true if atomic operations on 8-byte values are lock-free. false otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can... There is no field. 4-byte atomic operations are always log-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does...
Oh, it mentions 0 times. That's cool. Oh, because it's...
See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend.
I'm gonna just skip this.
A Boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the 3 agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62.
And then on the Rice computer, it's fast. What is it?
Where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents and any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated...
This seems XP does not doing extra stuff.
History, and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until the dedicated worker is activated again, if...
It's still merging. Oops.
Worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wait collect. An embedding may terminate an agent without any of the agent's cluster's other agents prior.
I think the JavaScript compiler
Is terminated not by program.
Are you kidding me? This thing's cutting out.
But by
The JavaScript compiler
then the embed.
is actually better than the C compiler. With loops, at least. Unless it's just, the timing is so bad Wait, what? I have no idea what. Yeah, okay, I'm just gonna run my speed test.
In a cluster, the field of the cluster is set to candidate execution. The initial candidate execution.
It's really painful to like line up. Freaking.
ECMA International 2024-163, an agent does not cause another agent to become blocked except via explicit APIs that provide blocking. 0.10 Processing model of weak ref and finalization registry targets 9.1.0.1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which do not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen
Subtract 2.
undefined as not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup call. Registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution.
It's a little over twice as fast as a 15-year-old computer. So I was expecting bigger, like maybe like 4 times faster. So Bowser only does about twice as fast as hold on.
This is an execution whereby the abstract operation weak ref dir for the weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sexcst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness.
This computer is 2.8 gigahertz.
5. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3. Colloquially, we say that an individual object or symbol
It's rising, so... gigahertz. It's like 1 gigahertz faster. It's twice as fast. That kind of makes sense. Yeah, the 15-year-old computer is actually almost 3 gigahertz. Well, okay. That's it. So I guess the new computers, I don't know. Twice as fast. I'm so bored. It was so boring. That's done with. So this test works. Is it accurate or like comparable to C? I don't know. I don't think the C will merge the loops. So it'll probably maybe be faster. I have no idea now. I have no clue. I have to run to find out. And I could like finish converting it because I just changed it. I need some water.
U, E, capital F. E, G, I, S, T.
Okay, so this, I don't know, whatever. It works. Now I just have to. Run and see. This might be all I get done. If it is, that's fine. It means tomorrow. This is done. All I got left is mother loving ins. I got a tag with a new type and then converting it in 2 days. And then it's down to pickle business. I'll be or be.
That point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling
Pickle business.
E, N, Q, U, E, U.
Man, freaking bear.
T, I,
Is he still reading?
N, capital R, E,
Yes, it is, okay.
S, T, R, is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H, O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R finalization registry, the host-defined abstract operation, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R takes argument finalization registry, a finalization registry, entry 2 RNS unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R should.
I forgot to accumulate the loop counter. That's why.
Turns unused. ECMAScript implementations are expected to call clear-kept object.
Right here. This mother-loving zoom tool is pissing me off. It does not work. To increment the eggs. Stupid zoom tool. I forgot that. I forgot to increment it. Now it's gonna be out of bounds or something. I gotta fix it when I get back. That's what I forgot. Because it wasn't even looping. It was just doing the same thing. That many iterations. It wasn't grabbing. And the actual array. I need some water. I feel like I wasted a bunch of energy making this stupid test function. Dang it.
Perform. Host call job callback, undefined, cell, return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol. It adds the target to a list that will point strongly at the target until clear-kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. Capital A, symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, Any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility-related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descript to record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them.
food in my teeth. Oh, the mic was on. I made a rookie mistake. This loop here, and I gave the browser way too much credit. I forgot to increment the counter. So now when I increment the counter, it's not gonna be like, whoa, the browser's pretty good. Wow, it's better than C. It's because I forgot to increment the counter. So now, when I increment the counter, I'll see what the time is. It should be less surprising. I was so confused. I was like, what the hell? How the hell is it so fast? What is going on? So here. EAX, whatever. 0. Moved. It's not lag. So much lag. Here. Okay, so it's 0 and it's 0 because I didn't increment it. So does that every iteration. I should have. It's basically doing this. And this is almost a compile time constant, but it's not exactly. So it's literally taking this and throwing it around for this many iterations. Now, I'll make it do whatever half the iterations. Well, it is right now. It's gonna access every even. Every index. If it's odd, if it's like the number 9, it clips the 1, the bottom end, shifts the left 1. I could mask, but whatever. The compiler usually masks changes. Doesn't matter. I don't know, not with this, but with like if whatever. It probably wouldn't do it for this. It would do it for like an if-else test. It can't mask in this case. I think it would have to shift. It's gonna have to shift. Or the compiler could like sort of temporary variable. I don't know why I'm talking about this. There's a ton of things the compiler could do. But basically, this needs to be accumulated each iteration to actually access the array. So now I'll run it. Let's see what happens. And oh, it's will not copy. Did the browser say crash? Did I click the X? I don't know. Oh, it disappeared behind me. It's not fucking just fucking copy. Why? Okay, you see right here. It says the error's at not read property of warp of undefined. Right here. I'm setting it to EAX++. How's it out of range? So now I'm going to do if not every object EAX alert message blah blah blah. So I want to catch what is not defined because it just threw this error saying it doesn't exist. So now I'm going to catch it. Let's see. I'm going to run it. Oh. I mean, never mind. Which means that let's see to just duplicate. I have no idea. see if this will make it any slower. First for it is just a copy of serif, but it doesn't matter. This makes no sense. This timer has to be fucked up. I don't get it. How can you do this fast? Run this fast, whatever. Do something like this. You gotta do this in here. Look at that. Makes it this fast. So 1.6. Now, it might be something of a constant time. Like, it's not even the loop iterations, it's adding like one more variable, but not just an object. This makes no sense. The timer is not accurate. Because it feels like a way long time difference. So I'm gonna undo crap I just did. So now the AX is up at the top. And then down here gotta increment it. Gotta decrement this beforehand. Or run it. Now it's like even faster than all the other times. So apparently it's like faster to like actually access the fucking memory than it is to not. Which makes no fucking sense. This time whatever I just did. So now it's like looping. It's entering loop. So now I'm gonna like not increment this. I'll just set it to 0. So now it's gonna do however many iterations of 0. Which I forced here as default to this whatever. Just in case there isn't anything in the array. I'm gonna run it. Let's see. What time is this? So this timing, when it's 0, it's not. It's a constant. It's accessing the 0th of the array every time. The speed is this. I'm so tired. I don't even know. That means it took longer, right? Right? Or am I wrong? Right? I'm so confused and tired. JavaScript is shit. Like fucking shit. It makes no sense. It's on purpose, the timings. They're like, don't worry about how long it takes. It's just a butthole. No one wants to like look at their ass when they wipe it. Don't worry about the timing. Performance doesn't matter. JavaScript is shit. So, with this counter here, I'm going to actually access the object or array. I'll print it too. And so this is with accumulating. We're looking at 1618 because I had to print. Printing this took a bigger impact on the time. So now, instead of this, I'm going to set it to 0. So never mind. I guess it is faster to use a literal, but not this time. But I guess this time. Oh wait, maybe not. Oh, seems to be slower. It's about 600. So apparently, if you loop over the same thing, object array, 2,500 times, right? So you access the same thing 2,500 times, the same thing, the same slot. It takes. I changed it 1.1 millisecond more, or second, whatever. It takes this long. Okay, so now see how it says count here 0. I'm going to just put the count there for real. So now EAX is incremented every time, which means now instead of accessing the 0th 25,000 times, it will be accessing the 0th, 1st, 2nd, 3rd, 4th, 5th, all the way up to 25,000. And I'm going to run it and see what speed is. And it's faster to put that comma for 2,000, 25,000, 250,000. I'm so tired, I don't know, whatever the number is. This many iterations, accessing the 0th this many times in a loop. This is fast. But accessing for this many iterations, that many items, like each item, 0, 1, 2, 3, all the way up to 25,000. Right here. It accumulates from 0, each one. It's inside of this. For that many accesses, it's this fast. You see this? Like, am I missing something? Right here. I'll just drop this 1 to 599. Why is there a... How's it 40? What is that, 6 to 9, 10, whatever? How's it faster to actually access this memory? All this many, all of them. How's that faster than accessing the 0th that many times? This bitch, whatever, this item, it should be so cached that this number drops lower, because you're accessing the same thing over this many times. So how the fuck is the same thing accessed that many times slower than accessing actual different items that many times? How? This is a joke. This is JIT compilation shit. For fuck's sake. It's on purpose too. You gotta keep it artificially timed. Is it gonna be like the same? Does it compute the same thing after some iterations? It doesn't. It's like actually somewhat. I don't get it. So, I guess it doesn't matter if I accumulate this counter here or not. But to make it fair, I'm gonna just accumulate the counter. Chatbot said that I'm not even gonna bother to get distracted. Chatbot said though that JavaScript has like inline caching, and you can rely on the JIT compiler to cache things or access. Right. So this runs. It doesn't matter if this is 0 or accessing that many items. I'm going to stop talking. Oh man, this took so long. I don't know. This is somewhat of a fair test, I guess. Whatever that means. I'm gonna run this in my JavaScript Engine. And 1315 with 14. If my JavaScript engine is faster than this, I don't know, 5 is between 3 and 5, almost a 6, 4, so 4. So I'm gonna go with this. I'm gonna convert this now. I can't waste any more time. This took so long. Like, it doesn't matter if it's nothing is optimized in this shit. It's just the number of operations. The memory access is the same speed. I think it does loop purging. I doubt it does unrolling. Everything's the same time though. It doesn't matter if this is actually accumulated or a constant, because it's going to take the same time to access. They're both stored as the same value, the same reference, the same time to get it, whatever. When you access it, it's so slow that it doesn't matter how fast it's accessed, because this should be cached, but since it's so slow to access an item, it's just as slow to access the 0th this freaking many times, whatever, than it is to access each one of them once. So, cache lines, whatever, there is no caching in JavaScript. it destroys the cache. Otherwise, if these things were ordered sequentially, accessed and whatever, it would pick up speed because it's accessing things that have been prefetched for the next catch by the hardware, assuming it has a hardware prefetcher. I don't know. JavaScript is shit. Just total shit. Okay, so I got that on my system. Or the modern JavaScript implementation is shit. Absolute shit. I'm gonna call mine the future JavaScript implementation. It's beyond modern. This is a joke to call modern. Like an 800-page documentation. They invest the time. I don't think these people can get paid. They invest the time to meet all this stuff, and it runs like a turd. Like a fucking turd. Like a dog pooped on the bed turd. I don't want to say certain people's names. You know, whoever blamed the guy, said, oh, the dog pooped on the bed, but it's like a really big poop on the bed. That lady, man, human. I don't want to say names. I probably shouldn't say names. This is a generic story. Any girl, person, could poop on a bed and blame it on, like, the Chihuahua. It wasn't a Chihuahua. That's the point, because I'm not being specific. I'm just, whatever. That's what JavaScript is. The modern JavaScript. So I'm gonna just say this is how fast JavaScript is. Because JavaScript can't even fucking time itself. Did I do the space after a mess? Does it make it easier to read? I think it might. It's like a little bit, a tiny bit easier to read. So. Implementation, I'm too tired to care. I don't care anyways as well. Now, what I wanted to do was move this outside of the loop. I'm gonna try it anyways. I'm gonna adjust this loop to like do a teeny bit, a very small amount of optimization to see if it makes a difference. And then I'm going to convert this. It's probably gonna take an hour or two. This is all I'm gonna get done. Dang it. So I'm gonna try to optimize this, see if it makes any difference. Okay, so as an attempt to optimize, I create this object outside of the function and the loop. It's inside of scope. So outside of the scope, it doesn't exist. It's created once. It's not created. Something, whatever times. It's only created once. Each iteration, it exists. Just overrides it each time. And every time that it has to save it, right here, I'm going to set it equal not to pixel magma, but to this object, which is these braces, how you make an object. The keys, the same key name to the key value. So it's a copy to a new temp object. So now it makes this object once. And how many does it keep these? How many times does it keep? It's keeping half of the total, I don't know, whatever. However many times, it's making less objects in total. Unless it's optimizing behind the scenes, and I don't know. And it only makes one allocation every time, which wouldn't be possible, I don't know. Whatever it's doing. I'm gonna see if this makes any difference. To make a copy of an object only, when it has to save it instead of every iteration. But it is possible it could optimize and catch it and go, oh, let's not make it every single time. Or it might be local and they just override it anyways and they don't bother to make a new object because they can tell it doesn't, whatever. And that sets these two items in the loop. Maybe I should I'm just gonna run it first. You could optimize these out because I know it's not being accessed. Here's it running. After attempting to optimize. That's kind of funny. I got what are the odds? Like really tiny odds. Yeah, 1, 2, 3, 4. So it made it faster. But not faster because it was like a 400. No, it is faster. Whatever, I'll run it again. That's why I'm doing this test in the first place. This comparison speed test. Doesn't it? It's enter here. Okay. So let's calling this. Okay. So all the code that I'm running or that I speed test is like same. It's not like none of my code that I test creates this. I'll see if this makes a difference. So I'm gonna keep what I have down there. I'm also going to make this every iteration. and see how fast it is. Slower. So now it says 1303. One more time. Now it's even slower. Okay, so this is the speed of this is optimization, but it's making it every time, so it's still slower. But I think that actually happens to be faster doing this, making a copy of it faster than just assigning it to a reference. So this is slower. So this is back to the original code. That makes no sense. What the heck? Now this is even slower. Well, no, it's not. It's like the same as this speed. One 400. He's being lenient. I'm gonna give it 1,500. Just because it's annoying me. Because now the speed is 1,500. 1.5, whatever. So it's slower to save a direct copy here inside the loop, making a straight up reference to it, a straight copy of a local loop variable object. It forces it to pull it from local scope to global scope, which makes it slower right here. 1.3, 1.4, 1.5, 1.6. But if I undo it, so this is just assigning it. But if I make a copy and assign it to a new object that holds it, so I copy all 4 of them individually to a new object. Since this is outside of the scope, here, it doesn't get the penalty of being made and pulled to the other scope, possibly, if that is what's happening. Because now the speed is this. So now the speed is this, which is faster. It does make sense, but if I move this out of here, so now it should only make a 1 and not at the top every time. This is fast. Oh no, it actually happens to be faster. Okay, Okay, so I'm just gonna go with whatever it is right now. So assuming it's true, because it looks like it is, by optimizing, or trying to optimize JavaScript, moving this outside the loop, and making a copy of it here, all the properties individually to a new object, is faster. It's the speed. I'm going with this one. It's best. That is faster than the one here. And the paste. So this is faster than this. This water. Isn't this one? It makes this object every single iteration and only saves it for however many iterations. That's slower. Okay, so this is why my whole point. I wrote any of the tests I do, they look like this. This one. Where there's like some attempt to optimize and not waste memory. Even though it should be garbage collected and there should be no memory loss, there is a waste in memory because it's just waiting to garbage collect. That's probably affecting the time on the other loop. Okay, anyways. Most of my code looks like this I'm testing with my JavaScript engine here. I have not written something that does, I haven't written code that does something like as reckless as creating an object on every single iteration inside of a loop when I'm only going to save however many of them, because that's just ridiculous, especially if you know that's a language that leaks memory. You'd be like, I'm not going to do this because it's going to have memory leaks. But nobody knows how the computer works, or even whatever. Not the computer, how the context that the current modern whatever. So I'm going to convert this right now. I'm going to run it because I don't have code that looks like this. So when I run this, or does this makes a new one every time, I'm going to find out if I can beat this time here. Here. So if I can beat this time, then I'm like, okay, even with crap code like this, mine's faster, my JavaScript engine. If I ran this test here, right here, I'm like 100% certain that my JavaScript engine would be faster in this case, because this is how I would have written it, like this, outside the loop, and only save inside the loop. And since I would have written it that way, and I know like the access times and the logic, this has less overhead writing it this way and doing this. So I know technically that mine is most definitely faster in this case. So I'm going to run this one. I'm going to convert this too. It's like the same thing. So I'll convert this also after. And I've got to beat this time, I guess. It's 1189. So this one, I'm certain that my engine's faster. This one I'm not. if it ends up being faster, in this case, then I'll feel certain that any code in my engine will be faster, unless it's like some special Chrome API function, like I'll call it browser. Unless it's something like browser thing, quicksort, API call, where it's like, I don't support that because I didn't do the standard yet. But when I do the standard, I'll have most of these things. But if I compare like something like this against my JavaScript engine, this will be faster, because this isn't even, it's not even going to be written in JavaScript, whatever this call is. This would be like a C program that they call from JavaScript. I'm talking about pure JavaScript, not like the property add-on calls, whatever. Pure JavaScript will always be faster. Most likely, like 98% of the time. So I'm gonna drink some water. I'll be back. I'm gonna convert this. I'm not gonna talk. I'm gonna sit down. I'm just gonna fucking convert it. I'm gonna run it. Test the time. That's what I'm gonna do. And then I'll have like an hour maybe to work on these. Maybe I can get what's left in an hour, and then 2 days left on the countdown. I doubt it, but maybe tomorrow and another day I could do all this, convert it all, and then I'm on pickle business, and I'll have to open up the program I spent a year on last year. It was supposed to take 4 months. It didn't take 4 months. It took a year. It got complicated, and I'm a purist. So, anyways, like programming purist, I don't mean like my program's like logically pure or whatever. Like I have like a concept and I follow it through. I don't make like exceptions or like break some kind of like whatever. Then I'm gonna have to pick up business. I'm gonna have to test these both. I talked about them earlier, whatever. Whichever one that's faster is what I'm gonna use. I'm gonna rip out the paging, call my API for memory management, or I'm just gonna replace malloc straight up with my memory API thing. And now my sales seller. I need some water. So then I want to pickle business. After pickle business, I want to make a OpenGL test thing to show that it's faster. My engine. Okay, whatever. After all that, then it's on to ECMA or here, and it's this for 2 months hopefully, and then I'll have a complete JavaScript engine. Get some water. After I drink the water I have, I'm gonna convert this shit and run it. Undo something I'm supposed to. Do this one. Save a copy. So I think this was so. And I'm gonna consider this as a sign of luck that it's all gonna be okay, and that I was worried about nothing. I just wasted all this time making this test when I really didn't need to, because it's already fast. That's my hope. It should be true. But now I got this far, I'm gonna test it, find out. I don't even know what does 1, 2, 3, 4 mean. God, it just won't click, stay. So I'm gonna Google what 1, 2, 3, 4 means, and then I'm gonna take a break because I need some kind of distraction right now. So that's chatbot, I guess.
What does 1 to 3, 4 mean if it has a meaning, like, other than a number that represents 1? What does 1 to 3, 4 mean if it has a meaning, like, other than a number that represents 1, 2, 3, 4? Great question. On the surface, 1, 2, 3, 4 is just a number, 1234. But outside of it literal...
It's not the surface, it's just a number.
Great question.
Why did it restart? Oh well.
Great question. On the surface...
I don't know why they have a pause button. It just restarts it. Like, this, I don't know, it doesn't make sense. I thought it would pause, but it kind of just resets. I don't know. I guess the symbol, that pause symbol, I guess on the surface, it looks like a pause symbol, but outside of that, it has a literal meaning. It looks like a pause symbol there, see when I hit play, but outside of that, the literal meaning is restart from beginning. And then stop, the stop button. This is the modern operating system, you know? I'm just pointing that out, no. So on the modern operating system, when you're playing voice, text, whatever, to text, this on the surface. Let me zoom in here. I shouldn't be wasting my time, but okay. This is a modern operating system. I've highlighted this text on the modern operating system. So Siri is going to read this text, convert to speech. And as you can see, this play button on the surface, it looks like a play button. So I'm gonna hit play. Okay, so it does play. And the pause button on the surface, it looks like a pause button. But when I pressed the pause button, that was only surface level looks. When pressed, the pause button actually has a literal meaning that is restart. Because when I press play, you see how it restarts?
This 1, 2, 3.
Oh, I was holding down the button. Okay, what I just said, again, okay, so I hit play. When I press pause, instead of pausing, it's going to reset.
Great question. On the surface,
So that should have paused. So when I hit play, it doesn't pause.
great question. On the surface, 1. Great question. On the surface, 1, 2, 3, 4 is just. Great question. On the surface, 1.
Like, do you see what I'm saying here? This pause, the stop button on the surface, it looks like a stop button. But outside of that, the literal like surface looks, it actually is a reset button. So when I hit stop, it doesn't actually stop. It resets.
Great question. On the surface, 1, 2, 3, 4 is just a number. Great question. On the surface, 1, 2, 3, 4. Great question. On the surface, 1. Great question. Great question. Great. Great.
And that is the modern operating system. I rest my case. I need to stop wasting time. I didn't know what my case was that I was making. Oh, that it's modern. That's what my case. This is the modern operating system. On the surface, it looks one way, but
But outside of that literal meaning,
it's not. It just looks that way. It really just does whatever it wants to do, and it's not what it looks like. Modern is as modern does. So here's what it says about 1, 2, 3, 4 though. This isn't even exciting. Ooh, there we go. But let's get a witch.
numerology symbolism, if you're into that. In numerology, 1, 2, 3, 4 is seen as a number of steps or progression. Some interpret it as a sign of alignment or personal growth. Spiritually, sometimes called an angel number, though this is not scientific. Some interpret it as a sign of alignment or personal growth.
Alignment to what? I wonder. What could be aligned for? I don't know. Who knows what's gonna happen. But this is the modern operating system, so it doesn't really matter. I'll BRB. I'm gonna get back and waste less time and speed test this after I convert it. It's so late now.
he exec. The execution context stack is used (54) Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing C. Last null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module, 4.2 resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then a set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference, env, name, strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Return env rec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Assert. env rec has a field. Return env rec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 Host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG specification, https://html.spec.whatwg.org/ For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback. V. Arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record. and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enq generic job must conform to the requirements in 9.5 host enq promise job, realm. The host-defined abstract operation host enq promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enq promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or module at the time host enq promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enq promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking PROLOGUE prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/#entry concept, 5.6 host enq timeout job, realm, milliseconds. The host-defined abstract operation host enq timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enq timeout job must conform to the requirements in 9.5. 9.6 Initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global. This value 0. Let global obj be Set default global bindings. Realm 1. Create any host-defined global object properties on global obj. 2. Return unused. Point 7 agents. An agent comprises a set of ECMAScript execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols, initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field. 4-byte atomic operations are always log-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, Resume forward progress. An agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock. Say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of...
If you're watching this stream, just stop, go live your life. Just go. Go away.
of the following
Live your own life. Don't watch somebody else do something. Go away.
to exactly one agent cluster. Candidate execution record. Shared data block. Waiter list record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agent's WinPer. Agent resource accounting indicates that the agent is runaway. Note 6 all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7 an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9 forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. Capital A, an unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10 processing model of weak ref and finalization registry targets 9.10.1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent if undefined is not returned, is kept alive so that subsequent, synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept object's abstract operation, when an object or symbol which is registered with the finalization registry becomes unreachable. A call of the finalization registry's cleanup callback may eventually be made after synchronous ECMAScript execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref derf of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec.cst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak refably, virousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024. There exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value Do I set R to set R to empty. D for each week set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead, variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited. Because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R finalization registry, the host-defined abstract operation, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024 9.12 Add to kept objects. Value. The abstract operation add to kept objects takes argument value. an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O. If P refers to a writable data property on the ECMA International 2024 167 object, set access of P on O creates a new data property named P on O. If P refers to a non-writable data property on the object, set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a boolean valued E internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descript to record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O10, 1, 1. 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O10, 1, 2. V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O, v1 0, 1, 2, 1 ordinary set prototype of O, v. The abstract operation ordinary set prototype of takes arguments O, an object, and v, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, v, current, is true. Return true. Let extensible be O if extensible is false. Return false. Let bev. Let done be false. Repeat. While done is false if p is null, then I set done to true. Be else if same value, p, O, is true, then I return false. See else. I if p is not the ordinary object internal method defined in 1 0, 1, 1. Set done to true. 2. Else. Set p to p, set o to v, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. A 1 0, 1, 3, 1 ordinary. Y is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O 1 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. A 1 0, 1, 4, 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5, p. The internal method of an ordinary object O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O, p1 0, 1, 5, 1 ordinary get own property. O, p. The abstract operation ordinary get own property takes arguments O, an object, and p, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key p, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is p. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6, p, desk. The internal method of an ordinary object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define own property. O, p, desk 1 0, 1, 6, 1 ordinary define own property. O, p, desk. The abstract operation ordinary define own property takes arguments O, an object, p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O, p. Let extensible be is extensible. O, return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current. The abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert, is property key, P, is true if current is undefined. Then, if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose, and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert, current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has an field and desk is not current, return false. If this generic descriptor, desk, is false and is accessor descriptor, desk, is not as accessor descriptor, current, return false. D if is accessor descriptor, current, is true, then I if desk has a current. 2. If desk has a current. Else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then if is data descriptor, current, is true and is accessor descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property Y whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor, current, is true and is data descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, Let enumerable be desk. Else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. See else. I for each field of desk. Set the corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7, 1. Ordinary has property O, P. The abstract operation ordinary has property takes argument so, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent. P5. Return false 0, 1, 8. The return ordinary get O, P. Receiver ECMA International 2024 171 10 1 8 1. Ordinary get O, P. Receiver. The abstract operation ordinary get takes argument so, an object, P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return. Call, getter, receiver 0, 1, 9. The return ordinary set O, P, V, receiver 1, 0, 1, 9, 1. Ordinary set O, P, V, receiver. The abstract operation ordinary set takes argument so, an object, P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O, P. Return ordinary set with own descriptor O, P, V. Receiver own desk 0, 1, 9, 2. Ordinary set with own descriptor O, P, V. Receiver own desk. The abstract operation ordinary set with own descriptor takes argument so, an object, P, a property key, V, an ECMAScript language value, receiver, an ECMAScript language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be O, B. If parent is not null, then I return parent. I set own desk to the property descriptor undefined, true, true, true. If is data descriptor own desk is true, then 72. ECMA International 2024 ABCDE. If own desk is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver, P. If existing descriptor is not undefined, then if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor, V. I've return receiver, P, value desk. Else I assert receiver does not currently have a property P. 2. Return create data property, receiver, P, V. Assert is accessor descriptor, own desk, is true. Let setter be own desk. If setter is undefined, return false, perform, call, setter, receiver, v, return true, 0, 1, 1, 0, p. The internal method of an ordinary object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return, ordinary delete, O, p1, 0, 1, 1, 0, 1 ordinary delete, O, p. The abstract operation ordinary delete takes arguments O, an object, and p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be O, p. If desk is undefined, return true. If desk is true, then A remove the own property with name p from O. B return true. Return false. 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, O 1, 0, 1, 1, 1, 1 ordinary own property keys, O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys 5. Return keys 0, 1, 1, 2. Ordinary object create, proto, additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object. Internal slots list. Set O to proto. Return O. 0, 1, 1, 3. Ordinary create from constructor. Constructor. Intrinsic default proto. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto as used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto as this specification is name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor. Intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create. Proto. Slots list. 0, 1, 1, 4. Get prototype from constructor. Constructor. Intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be get constructor prototype. If proto is not an object, then let realm be get function realm constructor be set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174 ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Internal slot. The abstract operation require internal slot takes arguments an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of the code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript funct on object may be either strict mode code 1122 or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to an ECMAScript function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Construct kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode, lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30. Internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, This is a list representing the non-static private methods and accessors of the class. Class field initialize a name, a string, a symbol, a private name, or empty if the function is created as the initializer of a class field. The name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If F is true, then a let error be a newly created type error object. B note. Error is created in callee context with F's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f. 1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. 2 Ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMAScript function object, callee context, an execution context, and this argument, an ECMAScript language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert. Global env is a global environment record. 3. Let this value be global env. Be else. I let this value be. To object. This argument. 2. Note. To object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value. This value. 0. Return unused. 0, 2, 1. 3 Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return. Evaluate function body with arguments function object and arguments list. Concise body, expression body, return. Evaluate concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body, function body, return. Evaluate generator body with arguments function object and arguments list. Async generator body, function body, return. Evaluate async generator body with arguments function object and arguments list. Async function body, return. Evaluate async function body with arguments function object and arguments list. Async concise body, expression body, return. Evaluate async concise body with arguments function object and arguments list. Initializer, assignment expression, assert. Arguments list is empty, assert. Function object is not empty if is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression, be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert. Arguments list is empty, return. Evaluate class static block body with argument function object, 0, 2, 1. For ordinary call evaluate body, F. Arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMAScript function object F takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F if kind is base, then a let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepare for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call binds this. F. Callee context. This argument, be let initialize result be completion, initialize instance elements. This argument, F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. see if result is not undefined. Throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert this binding is an object. 4. Return this binding. 0. 2. 3. Ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMAScript function object. It is used to spec the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1.0.2. 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical this, set f to lexical. 0. Else if strict is true, set f to strict. 1. Else, set f to global. 2. Set f to false. 3. Set f to env. 4. Set f to private env. 5. Set f to get active script or module. 6. Set f to the current realm record. 7. Set f to undefined. 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len. 3. Return F. ECMA International 2024 179. 10. 2. 4. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. F. Realm. The abstract operation. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. Takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw a type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor. F. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMAScript function object, a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then a assert is constructor, f is false, b assert. F is an extensible object that does not have a prototype own property. C set f to the definition specified in 1.0.2. 2. Else a set f to the definition specified in 1.0.3. 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. %object prototype %. B perform. Define property or throw prototype constructor property descriptor f writable prototype false true perform. Define property or throw f prototype property descriptor prototype writable prototype false return unused. 80 ECMA International 2024 102 6 make class constructor f. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0, 2, 7 make method f home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0, 2, 8 define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert home object is an ordinary, extensible object. If key is a private name, then a return private element. Method closure 3. Else a let desk be the property descriptor. Closure true, enumerable, true. B perform. Define property or throw home object, key, desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9 set function name f name prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert f is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name, then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f name property descriptor name false enumerable false true return unused. ECMA International 2024 181 the 10th of February 2010 set function length f length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert f is an extensible object that does not have a length own property. Perform. Define property or throw f length property descriptor length false enumerable false true return unused. 0, 2, 1, 1 capital F U N C T I O N capital D E C L A R T A N T I A T I func arguments list. The abstract operation capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be as simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a for binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note: if there are multiple function declarations for the same name, the last declaration is used. Insert d as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, Do a let already declared benv has binding. Param name b note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then I perform env create mutable binding. Param name false 2. If his duplicates is true, then perform env initialize binding. Param name undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object arguments list be else. I note a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructure parameters. 2. Let AOB create mapped arguments object func formals arguments list env. See if strict is true, then I perform env create immutable binding arguments false 2. Note: in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. Else I perform env create mutable binding arguments false. Perform env initialize binding arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else let parameter bindings be parameter names. 4. Let iterator record be create list iterator record arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else I perform iterator binding initialization of formals with arguments iterator record and env27. If his parameter expressions is false, then a note only a single environment record is needed for the parameters and top-level vars. Be let instantiated var names be a copy of the list parameter bindings. See for each element n of var names. Do I if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding n false. Perform env initialize binding n undefined. D let var env be env28. Else a note a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I if instantiated var names does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding n false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined 4. Else a let initial value be env get binding value n false. Perform var env initialize binding n initial value. Note: a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note: an xb 3 2 1 adds additional steps at this point. 0. If strict is false, then a let lexenv be new declarative environment var env. B note: non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else a let lexenv be var env. 2. Set the lexical environment of callee context to lexenv. 3. Let lex declarations be the lexically scoped declaratio ns of code. 4. For each element d of lex declarations, do a note: a lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d. Do I if this constant declaration of d is true, then perform lexenv create immutable binding dn true 2. Else perform lexenv create mutable binding dn false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lex env and private env. C perform var env set mutable binding fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1. A built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 10.3. 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 10.3. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 10.3. 1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f. This arguments list, undefined 10.3. 2. Arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in car, ll or construct, f, uninitialized, arguments list, new target 10.3. 3. Built-in call or construct, f. This arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, a new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix, The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string, and returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0. 4. 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in table 30. Instead, they have the internal slots listed in table 31, in addition to table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMAScript language value the value that is always passed as this value when calling the wrapped function. Bound arguments a list of ECMAScript language values a list of values whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor. Target is true. Let bound args be f. Let args be the list concatenation of bound args and arguments list. If same value, f. New target is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1. 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values. And returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1, 0, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 1, 0, 4, 1. 2. Set obj to target function. Set obj to bound this. Set obj to bound args. 0. Return obj. 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. Copyright sign, ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs.
What are the odds of it being 1, 2, 3 minutes and then 1, 3, 2? I don't know. Well, they're actually pretty good odds because it takes like a minute and 30 seconds. Whatever. This is so boring.
Yes, at.
So I'm like, run it. If it runs,
Desk is false. Return false.
it just means it built. I like defined a couple types.
I have succeeded is false. Return false. Jave.
It doesn't actually do anything to the defined variables, whatever yet. That's what I do now after I run it. I just want to make sure like this is working at least. I can like at least, I don't know, whatever. I think I have all the macros I need.
Desk 0.
I'm gonna build it then BRB.
Length. Proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and
I thought I had all the macros, and then I didn't. But now I do.
to specify the creation of new arrays. It performs the following.
Paste it all in place.
Prototype %. Let A be make basic object. Set A to proto. Set A is specified in 1, 0, 4, 2. 1. Perform. Ordinary define known property A. Length. Property descriptor. Length. True. False. False. Return A. 0. 4. 2. 3. Array species create. Original array. Length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array, original array. If is array is false, return array create, length. Let C be get, original array, constructor. If is constructor, C, is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then
It builds. Finally. So I'm gonna like use log out. I'm gonna whisper into the microphone. Like that guy that stole the election. He liked to whisper into the microphone. It's so cringy. It's like so cringe to whisper into the microphone. Really cringe. Alright, so I think everything's working. I'm gonna check the logout. I gotta Control F and then find where
82. Desk. Let number len be.
where it prints this shit.
New len. Number len is false. Throw a range error exception.
Alright, it prints.
Len desk be ordinary get own property A. Length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0.
I might have an issue, I don't know.
Desk 1. If new len old len, then a return. Ordinary define known property A. Length.
Okay, no issue. No issue, it's all good. What the guy'd say that stole the election? Said my butt's been wiped or something. I don't know why you tell people that your butt's been wiped.
Deferred in case any elements cannot.
Who does that? Okay, I think, I'm so tired. I don't... Even if you can't even hint at the wipage of your butt without, like, admitting that your butt has or has not been. I should just, like, focus and stop whispering.
Then I set new len desk to 32.
Maybe if, he wasn't so busy with his butt being wiped, he would have been able to steal the following election.
Desk. I've succeeded to.
So...
False. B assert. Succeeded is true. 9. True. Using the standard built-in array constructor for a realm that is not the realm of the running execution context. Then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species cray. T. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects.
I got 4 types.
During index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length.
This one's for 59, 79, 5, 51.
Or simply, a string object, if its, and its other essential internal methods use the definition. These methods string create objects have they also have an internal slot 1 0 4 3 1 p. The internal method of a string exotic object s takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property s p. If desk is not undefined, return desk. Return string get own property s p 0 4 3 2 p. Desk. The internal method of a string exotic object s takes arguments p, a property key, and desk, a property descriptor, and return.
I have no clue what the logout is. It's so confusing.
Property descriptor, extensible, desk, string desk, return.
But I think it's working. Most likely. I have to like dig in the notes and stuff to figure out whatever it's logging.
It performs the following steps when called.
I think it's an ID. I don't know. I can't remember. But
In ascending order. To keys. For each shown property key p of O such that p is an array index and to an integer or infinity, p, len. In ascending numeric index order, do a append p to keys. For each shown property key p of O such that p is a string and p is not an array index. In ascending chronological order of property creation, do a append p to keys. 90. ECMA International 2024. 8. For each shown property key p of O such that p is a symbol. In ascending chronological order of property creation, do.
This looks a lot bigger than I thought.
Value. Prototype. The abstract operation string create takes arguments value, a string, type, and return. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1 0 4 3 1. Set S as specified in 1 0 4 3 2. Set S as
Somewhere I had a test whatever. Like some test code.
descriptor, length, false.
I made an anonymous object.
A property key, and returns a property descriptor or undefined. It performs the following steps when called. If p is not a string, return undefined. Let index be canonical numeric index string, p. If index is undefined, return undefined. If this integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. Str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index plus 1, 1. Return the property descriptor. Result str. False. True, false. 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its argument's object is either an ordinary object or an argument.
Somewhere I have a test whatever single code. Stupid tool. Magnifier, whatever it's called. Somewhere I have code that supports this syntax, but I can't find it. I don't have 2 hours to look for it, so I don't think I can do the second test, but I can do the first test. That's the only one I want to test.
Six. To identify them as such, note 1 while creating mapped arguments, object is grouped into.
So I don't know, because this is how like in the second test it assigns an anonymous object, like
1. Note 2. The integer index data.
like this whatever. I can't do this unless I find the macros to make an object like this. I have macros.
Changed into an accessor property. If the argument's object.
I have the macros to make an empty object, like this one, but not a object that has the property list present. I have it somewhere. I know I do, because I spent too much time setting that up. Or like have a separate counter that accumulates each time, and it's complicated. I gotta find it. I'm gonna take a break, drink some water. I don't know. This better be faster. It's not, I'm gonna explode or something. I'll probably start yelling. But if it works, I'm good.
The man and bike informing ECMAScript implementations. Note 5 ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor.
So, because I can't find the macro whatever to make this object an anonymous object with keys and values in it, comma separated. I could find it, but I don't want to spend 4 hours looking for it. I still gotta find the if macros. They're somewhere too. I'm gonna have to spend like way too much time trying to like find a couple macros. I'm probably gonna end up remaking them and finding them later and being like, shit, I wasted time remaking this when it was right here. That's what's probably gonna end up happening. I need some water, but since I can't do this, I could, I'm not spending 4 hours. There's so much code. I can't do this test, but this test, I'm pretty sure with mine will be faster because I don't know, it's set up to handle this, but to handle like crap code where it makes a new object every iteration, decides to keep it only every certain number of iterations. It is set up for this, actually, but I haven't actually tested code like this, so this one I'm gonna test. So I can't test the second one, but I'll test this one. I got these first few defined, or like initialized. I gotta find a stopwatch macro. So I'll find that next, and I'll put the top and bottom. And I'll run it. I gotta find a print macro. And the rest of it's like, I have all the macros and anything. Let me come in and see how I handled the scope completely different or whatever. But I don't know until I run it.
If is mapped is true, then assert.
So LBRB.
Is mapped by arguments. Objects are always writable. Be perform. Set.
Don't forget to hydrate and make sure your butt's been wiped. Like for real. Make sure your butt's been wiped. Don't be a baby. And don't steal elections. Okay, I'll be a baby. After I paste this. So I have to type it up here.
2024 193 104 4 6 create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. Percent object prototype percent. Set obj to undef. Ned perform. Define property or throw. Obj length. Property descriptor. Len. True enumerable. False. True. Let index be 0. Repeat. While int x. Len. A let val be arguments list. Index b perform. Create data property or throw. Obj. To string. Int x. Val. C set index to index plus 1. Perform. Define property or throw. Obj. At iterator. Property descriptor. Percent array prototype values percent. True. False. True. Perform. Define property or throw. Obj. Callee. Property descriptor. Percent throw type error percent. False. False. Return obj. 0. 4. 4. 7 create mapped arguments object. Func. Formals. Arguments list. Env. The abstract operation create mapped arguments object takes arguments func. An object. Formals. A parse node. Arguments list. A list of ECMAScript language values. And env. An environment record. And returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0 4 4 1. Set obj is specified in 1 0 4 4 2. Set obj is specified in 1 0 4 4 5. Set obj to percent object prototype percent 0. Let map be ordinary object create. Null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat. While int x. Len. A let val be arguments list. Index b perform. Create data property or throw. Obj. To string. Int x. Val. C set index to index plus 1 6. Perform. Define property or throw. Obj. Length. Property descriptor. Len. True. False. True 7. Let map names be a new empty list 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names. 2. If index len, then let G be make arg getter name env. Let P be make arg setter name env. Perform map to string index property descriptor get G false true. Set index to index 1 20. Perform define property or throw obj at iterator property descriptor %array prototype values true false true 1. Perform define prop rty or throw obj callee property descriptor func true false true 2. Return obj 0 4 4 7 1 make arg getter name env. The abstract operation make arg getter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value name false. Let getter be create built-in function getClosure 0. Note: getter is never directly accessible to ECMAScript code. Return getter 0 4 4 7 to make arg setter name env. The abstract operation make arg setter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note: setter is never directly accessible to ECMAScript code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be. If numeric index is not undefined, then I let value be typed array get element numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor value true true true. Return ordinary get own property p. ECMA International 2024 195 10 4 5 2 p. The internal method of a typed array O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be. If numeric index is not undefined, return as valid integer index numeric index. Return ordinary has property p 0 4 5 3 p. Desc. The internal method of a typed array O takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be. If numeric index is not undefined, then if as valid integer index numeric index is false. return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If is accessor descriptor, desk, is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh. Numeric int x, desk 7. Return true. Return. Ordinary define known property. O. P. Desk 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string. P. B. If numeric index is not undefined, then I return typed array get element. Oh. Numeric index 2. Return. Ordinary get. O. P. Receiver 0, 4, 5, 5. The. If P is a string, then a let numeric index be canonical numeric index string. P. B. If numeric index is not undefined, then I have same value. O. Receiver is true, then perform. Typed array set element. Oh. Numeric int x, v. Return true. 2. If is valid integer index. O. Numeric int x is false, return true. Return. Ordinary set. O. P. V. Receiver 96. ECMA International 2024 10456 P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string. P. B. If numeric index is not undefined, then if is valid integer index. O. Numeric int x is false, return true, else return false. 2. Return. Ordinary delete. O. P. 0, 4, 5, 7. The intern method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy st. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0 length in ascending order do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J. Order. The abstract operation capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexcst or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj if is detached buffer is true. Then a let byte length be detached. Field name value meaning object a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign ECMA International 2024 197. 3. Else a let byte length be array buffer byte length buffer order return the typed array with buffer witness record. Obj byte length 0, 4, 5, 1, 0 typed array create prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds tar record is true, return 0. Let length be typed array length tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size O. Return length element size 0, 4, 5, 1, 2 typed array length tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer O is false. Let byte offset be O. Let element size be typed array element size O. Let byte length be tar record. Assert byte length is not detached. Return floor byte length byte offset element size 0, 4, 5, 1, 3 is typed array out of bounds tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert is detached buffer O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else a let element size be typed array element size O. Be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a boolean. It performs the following steps when called. If is detached buffer O is true, return false. If is integral number index is false, return false. If index is -0, return false. Let tar record be capital M A K E capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O. Unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array OU T of bounds, tar record is true, return false. Let length be typed array length, tar record. If R int x 0 or R int x length, return false. Return true. 0, 4, 5, 1 5 typed array get element O. Index. The abstract operation typed array get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If as valid integer index, O, index, is false, return undefined. Let offset be O. Let element size be typed array element size, O. Let byte index in buffer be R, index, element size plus offset. Let element type be typed array element type, O. Return get value from buffer, O. Byte index in buffer, element type, true, unordered. 0, 4, 5, 1 6 typed array set element, O. Index, value. The abstract operation typed array set element takes arguments O, a typed array, index, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be to big int value. Otherwise, let num value be to number value. If as valid integer index, O, index, is true, then a let offset be O. B let element size be typed array element size, O. C let byte index in buffer be R, index, element size plus offset. D let element type be typed array element type, O. E perform set value in buffer, O. Byte index in buffer, element type, num value, true. Unordered. Return unused. ECMA International 2024 199 10 4 5 17 is array buffer view out of bounds, O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy S, T. B return is view out of bounds, view record. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy S, T. Return is typed array out of bounds, tar record. 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module, C16, 2, 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string-valued own property key is the string value of the corresponding exported binding name. These are the only string-keyed properties of a module namespace exotic object. Each such property H has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare f and 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6. P. Desk. The fi known property internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define known property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value desk. Current. Return true. 0 4 6 7. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true. Return false. ECMA International 2024 201 1 0 4 6 8. The. If P is a symbol, then a return ordinary get O. P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M. Resolve export P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace target module. 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value, binding, true 0, 4, 6, 9. The return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return. Ordinary delete. O. P. Let exports be O. If exports contains P, return false. Return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104612 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let m be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 1046. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare f and set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0, 4, 7 immutable prototype. Immutable prototype
The stream's at like, I think 10 hours. I don't know if we can get this, done in an hour and 20 minutes. So, I'm gonna like, really focus and stop talking for real. But, I don't know. I'm not gonna have time to,
prototype O V1047 to set immutable prototype O V the
I don't have time to move this window around because the magnifier sucks on Windows, this magnifier tool. So I might actually get this done in 1 hour and 18 minutes, which gets me at, man, this freaking tool, Windows. This is the modern operating system. So if I waste any longer, I have at least an hour to get this part done. I hate this fucking operating system. If I can get that done tomorrow, I have 2 days. This computer is so laggy. I can get these two done. And if I can get those done in 2 days, I hate everything. Then I'll be down to pickle business. And I will have made it just in time compiling, getting everything running, ready for pickle business, where I'm gonna have to like
use the definitions in this section. These internal methods are installed in proxy create table 34. Get prototype of set prototype of set prototype of is extensible prevent extensions get own property
I think it's pick a business. You don't have to
has property has get set delete property own property keys own keys
pick whichever pickle. I didn't realize how this kind of looks. Yeah, whatever. I'm tired. I circled both of these options, whatever, I talked about them earlier. So like, I have a multi-cache mode using a memory slab allocator I have, or if I'm using caching mode with removing the hard drive access. I don't know which is faster until I test it, so I'm gonna pick, because I'm in a pickle, I gotta pick which one's better after.
Subsequent invocations of internal methods on bit proxy object to throw a type error exception, because proxy object.
I finish up these 2 steps, if I can get this.
It is possible to define a proxy object whose handler methods violate.
Step here done in the next like hour. I probably spent 5 minutes talking right now, so I'm gonna try to get this done. I can't install. I don't have time.
ECMAScript implementation must be robust in the presence of all variant violations. In the following,
Time keeps ticking, so don't watch this. Go live your life. Do your own thing. I'm just like archiving this. If you're like watching this and you wait watching this for like a whole minute and a half as this builds, this compiler, whatever, you're wasting your time. Like, go away, do something else with your time, or watch it later, and then you can fast forward past 1 minute 30 seconds, because I have to wait for this every time. And if you're watching this and you sit here and watch it build, you are wasting so much of your time. So GTFO. I'm gonna like shut up and try to shut up. I got an hour left. I can do it.
handler proto is not null. Throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto target proto is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariance. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariance. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 105 3. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate no and revoke proxy.
Okay, I'm not gonna waste time talking. So since I'm not gonna waste time, I'm not gonna say that I'm gonna convert the loop part first, like the inside loop, because I have the macros. And then I'm gonna deal with the time or whatever. And then I don't know if I can find the macros to print the value of
It performs the
there to the console,
validate non-revoke proxy.
like it has like an internal data structure to the whole thing.
Get method
I don't know if I can find that, but
undefined. Then a return target. Let bool.
it is a pointer to memory location, and I can point to it, dereference it, and then cast.
Target be fixed.
Just cast it as size T, whatever,
Exception.
and I'll just log whatever the fuck it is. It might be an address, it might be a bit field.
Argument P. A proper.
As long as I dereference what the. It's only a single dereference inside of technically whatever. As long as if I dereference it, it guarantees that the compiler will treat it as existing whatever, and the compiler will it won't remove it stuff when it builds. So like parts of the code won't be dead code eliminated. So like even if it doesn't print the loop number and stuff, I'll just add a couple extra like normal standard counters in the loop to keep count, and I'll log those. I'll have to log that once too. I'm gonna log everything. I'm gonna log some extra stuff. I'm just gonna make sure the loop runs. All I need is the time. So I don't know. I just wasted another. That's my plan. I don't want to like do a mini stream for like 5 minutes. I gotta get it done before 12 hours. Because YouTube's worth however many billions, or they say, dollars, and they can't afford to like have 24-hour streams. They gotta limit the videos, the streams, whatever, to 12 hours. I don't get it.
Scripter.
I think with all that money, what do they do with all that money? They clearly don't update the web browser. It's nowhere near modern. I'm done. I'm gonna focus.
Throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error.
If this doesn't end up being faster, I'm gonna be so pissed.
2. If target desk is true, throw a type error exception. 7. Return result.
I forgot what I was gonna say.
The report is non-existent. If it is non-configured. The target object, a property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desk, The internal method of a proxy exotic object O takes arguments P, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then if extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else if is compatible property descriptor, extensible target, desc, target desc, is false, throw a type error exception. B. If setting config false is true and target desc is true, throw a type error exception. C. If is data descriptor, target desc, is true, target desc is false, and target desc is true, then if desc has a field and desc is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desc be target. P. B. If target desc is not undefined, then if target desc is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desc be target. P. If target desc is not undefined and target desc is false, then if is data descriptor, target desc, is true and target desc is false, then if same value, trap result, target desc, is false. Throw a type error exception. B. If is accessor descriptor, target desc, is true and target desc. 0.
I don't know what to name these variables. They're not constant, they're not literals, they're not defines. They are, I need a name.
corresponding target.
I need a fucking name to name these things.
Validate non-revoke. Let target handler BO. Set if trap is then a return target.
How about lar? Like literal variable. So it's like var with the L in front. I'll go with lar. I don't know. I need a name that I didn't use. There's so many things, names I use. I haven't used lar, so I'll name them lar. It's so lame. How about lus? Like lookup string. Or look, like lookup key. Or LSK, lookup string key. LSK. That sounds, I'll do LSK. This is such work. Or rainbow. I haven't used rainbow. I used unicorn for something. I'm gonna go with LSK.
The internal method of a proxy exotic object so takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target BO. Let H. Handler BO. Assert.
Instead, I'm gonna go with lol. L-U-L. Lookup literal. Or lookup. It's not a define. Or lua. Lookup. Or lus. I'm gonna go with lol.
P0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target BO. Let handler BO. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array. String. Symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then, I append key to target non-configurable keys C else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then, a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do, if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, Do. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let argArray be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. argArray. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let argArray be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P, 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let CP1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let CP2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0 XDC00. Return the string concatenation of CP1 and CP2. ECMA International 2024 213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics, UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0 XD800. 0 times 400 plus trail 0 XDC00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1. 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then A. Return the record. CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then A. Return the record. CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then A. Return the record. CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record. CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, see 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is passed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions. 15.2, arrow function definitions. 15.3, method definitions. 15.4, generator function definitions. 15.5, async function definitions. 15.8, async generator function definitions. 15.6, and async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20211, the generator function constructor 27311, and the async function constructor 27711. Note 2. The practical effect of including the binding identifier in functio encode is that the early errors for strict mode code are applied to a binding identifier, that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1. 2. 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1. 2. Strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive PROLOGUE are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use-strict directive and which occur in a directive PROLOGUE. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive PROLOGUE an expression statement that is not a use-strict directive and which does not have a meaning defined by the implementation. 1.1. 2. 3. Non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined with an ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input.
I can't make it in 12 hours. I gotta start another stream. So, there's no way I can make it. There's so many macros I gotta like copy and paste. It's gonna take another way too long. Alright, I'm gonna like let the stream go on for 10 more minutes.
Expression literal, a template middle, or a template tail is permitted.
Because this is a modern streaming software.
Grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template.
It's a modern streaming software called OBS. I highly. I guess there's nothing else to recommend, but if this was recommendable, I'm not saying it is or isn't.
And a leading regular expression literal are permitted.
I'm just saying
C12.
This was a 32-bit program back in the day.
CMap D.
And it's been updated to 32-bit. It's for streaming. So I would consider it modern. No, modern, because it's modern. It's been updated to 64-bit. And this streaming software, because it's modern, it does this thing where I end the stream, whatever, but my butt's been wiped. As that guy said, I don't know, whatever, this old guy, they like shook hands with ghosts and stuff. I think he ran a country. He'd always walk around saying that was butt. Anyways, but I don't know. Because this is modern, I guess it's the modern thing to do. Where when you click stop live stream on YouTube, live, whatever, it won't send the full stream. It might be missing that, like, the last 2-3 minutes. It could be missing 5 minutes. But 10 minutes? I haven't seen it miss 10 minutes. So I'm gonna, like, let the stream run on. I'll be back. I have to get this done today, whatever. I have to know. I gotta run this and speed test it. So I'm gonna let the stream run on for 10 more minutes. Because YouTube is also modern YouTube Live. And because YouTube Live is modern, YouTube Live doesn't support streams or videos longer than 12 hours. I'll Google really quick.
Control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals.
So, technically, within context, there is no time limit on YouTube live stream. However, YouTube can only archive live streams up to 12 hours long. So if you want your stream to be eligible for viewing at a later time, 12 hours is the maximum limit. So technically, within context, that's totally misleading. That's a biased, I don't know. So, the stream's almost at 12 hours. And because of that, I gotta end it. YouTube, Twitch, I don't know, they support longer streams. There's other streaming services I think they do too. I don't know. But YouTube does seem to be the most modern because they actually have streaming at higher than 180p, which is actually nice. Even though it's compressed, it has partial color, it's an option. Options are nice. A nice option would be streams longer than 12 hours. Maybe like 14, 15 hour streams. Just a couple more hours. That'd be nice. But no. So, I'm gonna let this stream run on for 5 more minutes. Because there's a 12-hour limit. This stream's at like 11 hours and 20, 25 minutes. Now like maybe 30, 40. And also because this amazing, beautiful, wonderful streaming software, because it's modern, it's really modern. It's 64-bit. Because it's so modern and hip, it doesn't always send the full stream. So, since I let this stream run on for 10 more minutes, I'm hoping that the entire stream will be sent. So I'll be back. And you shouldn't watch the next stream because, I don't know, just live your life. Don't bother watching. You're wasting your time if you're sitting here watching me compile this program. If you're sitting here, as I'm sitting here waiting for this to build, you are wasting your time because you get nothing out of watching it build, sitting here waiting. I have to physically sit here and wait to progress in life. And life keeps ticking away. Tick, tick, tick. So get the fuck up and do something. So I'll be back in, oh shit. I'll let it count down again from 10 minutes. I'll be back in 10 minutes. Start another stream. I can't. I'll say peace next stream, so it's not over yet. The show goes on. And on. And on. And on. And on. Okay, I'll stop. No.
Terminatus have some influence
Dear me.
in general.
Unless the internet goes up, then it won't be.
Places where they are forbidden by the syntactic grammar.
I don't know. Anything's possible.
Automatic semicolon insertion 12.10. Align.
It's not the 1970s. This is the modern 2025.
L, LF, and CM.
We live in modern times.
And accept as part of a line continue
Modern.
in a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. line terminator code points. Code point. Unicode name. Abbreviation. U plus 000. Line feed. LF U plus 000 D. Carriage return CR U plus 2028. Line separator. LS U plus 2029. Paragraph separator. PS. Only the Unicode code points in table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in table 36. The sequence CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax: line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line comment, single-line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars. Capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E. Multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E. Source character but not one of all. Single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, single line comment char. Source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax: hashbang comment, single line comment charsopt. 2.6 Tokens syntax: common token, identifier name, private identifier, punctuator, numeric literal string, literal template. Note the div punctuator, regular expression literal, right brace punctuator, and template substitution. Tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier start, identifier name, identifier part, identifier start, identifier start char, Unicode escape sequence, identifier part char, Unicode escape sequence, identifier start char, Unicode ID start, underscore, identifier part char, Unicode ID continue, ZWNJ, ZWJ, letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but Gustav Wexes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 1.2.9.4. Note 1t. His standard specifies specific code point additions, U+0024, $, and U+005F, low line, are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2.7. 1 identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2 identifier names that are canonically equivalent according to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2.7. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2.7. 1. Static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name. Identifier start. Let CP be identifier code point of identifier start. Return CP. Identifier name. Identifier name. Identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2.7. 1. Static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, The code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2, 7. 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of